Yeah, but I don't mind. Hey, and Carol, you won't believe this, but my brother Chuck, he texted me today and he says, when is this observatory open? Now, he never comes down. The last time that my family was at a PAL observatory is when I got married there.
Well,
and that
You're
was
married at the observatory?
I did.
Oh, wow. That's great.
Yeah, it was a big outdoor event and stuff, and that was quite a few years ago. And so anyway, he wants to come down and look through the telescope. So
that is so cool.
yeah.
Who said miracles don't happen?
Hi, David.
On there.
Hello, how are you?
Good to see you.
Good to see you again. How you doing, Chuck?
We're trying to do okay. I think we're surviving here.
That is a good thing. It beats the alternative.
It's quite a challenge.
Yeah,
but things went pretty smoothly the first two sessions.
You've only begun the marathon here, huh?
I know. It seems like one. You feel like you've been running all day and you're just a mile marker two, you know.
Jerry Lewis will have nothing on this group in the end here when you're done. Yeah.
The first two sessions went great. They were
good.
Everybody was on time and it was perfect.
Excellent.
Hey, Dave, do you still do stuff?
Today is the birth of Flamsteed, and Jupiter's at opposition today.
Whoa.
You want to read my horoscope?
Yes, I do.
I'm sorry, Brian, I didn't hear you.
Just asking if you still did the Civil War stuff.
Not so much. I'm actually going to go and take a trip in September for a couple of weeks to some of the battlefields out in the East for the first time in some years. But I haven't done, there's so much astronomy writing going on these days. I haven't done any Civil War book writing recently. I stopped at 9, never quite making 10 Civil War books, at least for the moment.
If we could have just set up a 20-inch Dob in the middle of the field at Gettysburg, I think things would have been entirely different.
Indeed, that would have been a cannon that would have impressed those who were familiar with 3-inch Napoleons. You know, would have looked like nothing compared to a 20-inch Dob. Yep. And of course, there was the famous tale of after the night after the Battle of Fredericksburg in Virginia, there was a very, very bright aurora. You know, the evening of that battle, which both armies thought was, you know, a sign of whatever you wanted to take it for.
Yeah. You know, Eisenhower's home was just right behind Gettysburg. It's just right behind where the Confederate lines were. Yeah. It's
administered by the Park Service. Yes, indeed. And of course, it was one of Abraham Lincoln's joys as an amateur scientist when he climbed up not at the Naval Observatory where the vice president's quarter is, but the old Naval Observatory downtown, you know, in what was Foggy Bottom at the time there. Lincoln went over there one night in 1862, climbed up the same ladder and hatch. You can go up into the observatory there now, if you know Jeff Chester or somebody who's there, and had ASAP Hall show him a number of sky objects. This was before Hall had discovered the 2 Martian moons, of course.
Wow.
So amazing how some of that confluences and intercepts history and also astronomy sometimes, you know.
I had the privilege of going to the U.S. Naval Observatory when I was a teenager. And thanks to Congressman,
I have to be
those are some happy memories. I got to look through the telescope. Today, the eyepieces are encased in a shadow box, and it has a label that says, in case of computer failure, break glass.
That's a great refractor. And of course, the only problem now with the vice president being there is you have to be subjected to a search and your car and the underside of your car inspected to drive in there.
Well, everyone, we're back. This is part 2 of day 1 of the 2021 virtual Astronomical League conference. I'm Scott Roberts from Explore Scientific and the Explore Alliance. And it's my privilege and pleasure to broadcast this event with the executives of the Astronomical League and all their special guests and presenters. So we've had a fantastic first session so far. And so I'll turn this directly over to Terry Meehan. Terry?
Thanks, Scott. And welcome back, everybody. It's always good to see everyone and see some friends' faces we haven't seen for a while, too. I'd like to give you a little bit of an idea of what is coming up. We do have the Horkheimer Smith Awards, some more youth awards. We have David Eicher, Chief Editor-in-Chief of Astronomy Magazine, coming up, speaking about galaxies and his new book, which is great. We have more door prizes coming. And for that, we would really like to thank all of our clubs. They have really came through and helped us tremendously. This would not be what it is if they had not stepped up to help us. It is amazing the outpouring of door prizes we have received. And so thank you to each and every one of you. We have Alan Dyer joining us, speaking about chasing the Northern Lights. We also have John Goss and Tom Lynch speaking about the Library Telescope Program and the Library Telescope Award. So with that, and like I said, we have 6 more door prizes coming up. With that, I am going to turn this over to Chuck Allen and let him present some awards. Chuck?
Thank you, Terry. I appreciate it. And what we'd like to do now is present an award in absentia. Vivek Vijayakumar is one of our most successful applicants for youth awards in the league. And I'd like to just make a very short comment about our league awards for youth. We have a National Young Astronomer Award program for research. We also have the Horkheimer Smith and Dyer Awards for service to both the league and or its league member societies that would go to youth who basically extend public outreach through their clubs or individually, maybe in their schools. We have a Horkheimer Parker Award with substantial cash prizes, by the way, go with these awards. The Smith and Dyer Awards carry $1,750 and $1,000 prizes. And our Horkheimer Parker Youth Imaging Awards, first, second, and third, carry $1,500 and $250 prizes and draw some amazing work. And we have also a Horkheimer O'Meara Journalism Award that's for 8 to 14-year-olds who write 150-word essays. So if you're engaged in service, public outreach, journalism and writing, if you're 8 to 14, or if you're involved in research on astronomy and you're not of college age yet, please consider applying for these awards. The deadlines are March 31st of each year. Okay, I'd like to show you via screen share here there we go. This is Vivek Vijayakumar. Again, he's the first person ever to win 3 National Young Astronomer Award prizes, first, second, and third place awards over the last 3 years. He also won second place in our Parker Imaging Award contest in each of the last 2 years. In 2020, his image of NGC 281, the Pac-Man Nebula, won second place in a $500 award for him. This year, his image of the Leo triplet won him a $500 award for the Horkheimer Parker Award. It's fantastic work for this young man. Here's a couple of images. Here are a couple of images of Vivek at science fairs where he's been very successful. He won a second place award in physics and astronomy, I believe, at the International Science and Engineering Fair. And here he is working with his telescope and camera equipment at home. He has a little video he'd like to show you, however, about his National Young Astronomer Award submission for this year, figuring out gas and galaxies in Enzo Foggy, and it has to do with inflows and outflows in the intergalactic medium. So I'll play that here.
Hello, my name is Vivek Vijayakumar, and this is my project at the Research Science Institute on the inflows and outflows in the circumgalactic medium. The circumgalactic medium is the gas that surrounds galaxies, and my project is mainly concerned with the inflows and outflows in the CGM. The outflows occur along the minor axis of the galaxy, and the inflows occur along the major axis of the galaxy. In order to study the inflows and outflows, we construct a simulation of a Milky Way type halo, which we label Tempest. And here you can see a density plot of Tempest, where you can see the relatively dense galaxy and the relatively low density outlying halo. We can first examine gas phases in the halo. So what we're looking at here is cold gas, which is less than 10 to the 4th Kelvin, and you can see that's primarily concentrated in the galaxy. When we get to the phase of cool gas from 10 to the 4th to 10 to the 5th Kelvin, we can start to see some of that present in the circumgalactic medium. And we get to warm gas from 10 to the 5th to 10 to the 6th Kelvin, we can see that's more homogeneously distributed. When we get to hot gas, which is over 10 to the 6th Kelvin, we can see that's primarily concentrated in the outflow region. And what we can see here is a clear difference in temperature between the galaxy, the circumgalactic medium, and then the outflows. Here we can examine the inflows and outflows with particular characteristics. So we can see here that the outflows are relatively low density but higher temperature, while the inflows are relatively high density but lower temperature. Using the radial velocity, which is a velocity away from the galactic center, we can cut the halo into regions so that we can examine the inflows and outflows separately for analysis. Doing so, we can first examine the orientation of the inflow and outflow regions. So we can see that the inflows primarily follow along the major axis of the galaxy, while the outflows primarily follow the minor axis of the galaxy. We can also look at the distribution of certain elements and ions in the circumgalactic medium, and here we don't really see a discernible difference between the inflow and outflow regions. And that's the same for oxygen 6. However, if we look at the ratio of oxygen 6 to hydrogen, we can clearly see that the oxygen 6 is primarily concentrated in the circumgalactic medium, but is of low concentration in the galaxy. And this indicates to us that it traces warm gas. We can also look at the magnesium 2, which is another ion, and we can see the opposite, where it's primarily concentrated in the galaxy, but it has a lower concentration in the circumgalactic medium, which means it traces cool gas. So potentially, we can use these two ions as tracers for the inflow and outflow regions, especially when we do observations. So to summarize, the inflow and outflow regions follow the major and minor axes, but we can't really see a difference between ion abundances. However, we can try to see how magnesium 2 and oxygen 6 can trace the inflow and outflow regions, despite our analysis including extraneous material in those defined regions. Future work can include creating spectra for direct observables to see what we can model, and also to use stricter inflow and outflow regions in order to get a more accurate analysis, and we can try to extend the work to higher redshift halos. I'd like to thank my RSI mentors and the people at the Research Science Institute for helping me conduct this project.
Okay. Vivek couldn't join us tonight because he's involved in getting settled down at Princeton University during orientation week. And this is the time of the summer when a lot of these seniors are headed to college. Connell Richards will be joining us in a future date during the convention, and he too will be broadcasting from his new college location at Penn State University. So with that, Terry, I'll turn it back over to you to introduce our speaker.
Thank you very much, Chuck. Tonight, we have David Eicher with us. Dave is the editor-in-chief of Astronomy magazine and has been since 2002. He's an author, co-author, and editor of 23 books on science and American history, and is also known for having founded the magazine, the astronomical observing magazine, Deep Sky Monthly, when he was 15 years old and a high school student. David's also a historian, which we have just talked a little bit about some of the history, and it's amazing to listen to you speak about that too, having researched and written extensively about the American Civil War. David's books include Comets, Visitors from Deep Sky, a book with Brian May of Queen fame. He is also involved with Starmus. Are you on their board, if I remember right?
Yes.
Starmus Festival, a science and music festival, which someday I am going to have to go to. That sounds amazing. And you know, he's a friend. We have seen Dave so many times on the global star parties with Scott, and I love your talks. So David, I am going to turn this over to you.
Well, thank you so much, Terry, and it's a pleasure to be with you. Thanks for having me here. Thanks to the League. Thanks to you, Terry. I've known you for a long time. We came out of that same illustrious region of Southern Ohio there.
Yes. Yes, we have.
It was either presidents, football coaches, or wayward astronomers, I think, one of the three.
I guess we're the wayward astronomers.
Thank you so much, Terry, and thanks, Scott, for facilitating this as well as always. It's a pleasure to be with all of you and see so many old friends even sitting here with me among the officers of the League. I wanted to talk a little bit tonight about Galaxies. One of my favorite books back in Ohio when I was a teenage lad attempting to grow up was a book called Galaxies by Tim Ferriss, the great science writer. It was published in 1980, and I was really just entranced with this book. It had sort of pseudo three-dimensional diagrams of where objects were within the Milky Way and of nearby galaxy groups to our own galaxy group and very distant large clusters of galaxies. And you could really imagine what was going on in the deep universe with this book. It was really a treasure. And so I thought to myself, boy, you know, I'd really love to write a book that's kind of an update to that book someday. Well, someday finally came last year. And so to make a shameless commercial presentation just for 1 second. So I published this book, Random House published this book called Galaxies. Also, that's an update, if you will, of a lot of what Tim talked about so well. And why should you do this, you might ask? Well, it's because the pace of astronomical research, as many of us know here, is so rapid and so all-encompassing now. We're really living in a golden age of astronomical discovery and research. And you might ask, well, what's really changed about what we know about galaxies over the since 40 years? And the answer is everything. So I'd like to talk tonight about a little bit of what we've discovered largely in the last 10 to 15 years about galaxies, which are, we like to say, are our fundamental large-scale building blocks in the universe. So it all began, I think I'll share my screen if I can, Scott. Let me see if this works from my end here. I will attempt to share this and let me know if you can see that.
Yes.
And whether I can commence a slideshow, and then you won't have to look at me, which will be a major improvement, looking at M81 instead. And I'll go right on to one of the most famous. You can see that okay, everyone?
Yes.
Good. Well, this is the story of one of the most famous moments in the history of astrophysics, which really began about the time of that American Civil War with the development of spectroscopy and other astrophysical tools. And a major moment came about 60 years later. It was October 4th of 1923 when a cantankerous young astrophysicist, Edwin Hubble, drove up from Pasadena, from his office in Pasadena there, up to the largest telescope in the world at the time, the 100-inch Hooker telescope at Mount Wilson. which, believe it or not, had replaced the previous largest telescope in the world for much of the 19th century, was in rural Ireland, built by an amateur astronomer. But the Hooker telescope by the time of World War I was the largest telescope in the world. It was great for discovering and studying distant objects. Hubble used to love to use it whenever he could with glass plates such as this one to study what he thought were spiral nebulae, as they were termed at the time, of course. And this was in a Los Angeles that was very, very different from the one we know now. It had a population of about 1 million at the time. At Caltech, Robert Millikan across town had just won the Nobel Prize in physics for measuring the charge carried by a single electron and for the photoelectric effect. Across town, a young Amelia Earhart was taking flying lessons, and a young cartoonist that year in 1923 arrived in Hollywood with $40 in his pocket, and his name was Walt Disney. Well, on Mount Wilson, Hubble was very excited and interested in looking at these spiral nebulae. And at the time, nobody really knew what the nature of these things was at all. Were they inside this giant sphere of what our galaxy was thought to be, whatever that meant at the time? Was that the whole universe? Were they distant things? There had been a famous argument in Washington, D.C., a great debate a few years earlier about it between two prominent astronomers. So Hubble really wanted to solve this mystery, and he took a famous plate of the Andromeda Nebula, as it was known at the time. You can see the center of the nebula here, of course, and was astonished because he thought, you can see near the top of the plate, he put a couple of tick marks on either side of a faint star, and was astonished that he had found a nova in this distant spiral nebula, whatever it may be. This excited him. He ran this plate down to his office, took another one the following night, and that's the plate we're looking at here. Actually, and he looked at the nova again and studied this resulting plate for several days, and it became one of the most famous photographs in the history of science, because he not only found out that this was not a nova, and you can see that he crossed out the N and wrote VAR for variable star, very large in red ink, but he compared it with earlier images that had been taken of this nebula, and found that it was not a variable star. It was not a nova, forgive me. It was a particular type of variable star called a Cepheid variable star, so named after the prototype Delta Cephei in the constellation Cepheus. And the precise and particular pattern of brightening and dimming was very, very well understood, even at this early phase in astrophysics of Cepheid variables. And so if you knew the exact way that these stars behaved, you could determine their absolute brightness. And by doing that, by measuring the apparent brightness, how bright this star appeared in our sky, you could then calculate a distance using this kind of variable star, this very special kind of variable star. So to Hubble's amazement, he found that it was 1 million light years away, his calculation. Now that was 3 times larger than the diameter of the entire universe that any astronomer imagined at the time. And of course, it turned out to be wrong. It was large, that figure, but it's actually 2.5 million light years away, we know now. So this was a breakthrough moment. It was a major moment in the history of astronomy and in science. And in that one observation, in its analysis, Hubble discovered the nature of galaxies, that they were huge systems of stars, gas, and dust, and also the first clue to what came to be called the cosmic distance scale. So this was a big, big moment for astronomy. The understanding of the universe and its size and the motions of galaxies and their so-called, somebody mentioned earlier, radial velocity tonight, I think, the motions mostly away from us, but a few of them toward us, led to the understanding by Hubble and by other astronomers, including V.M. Slipher at Lowell Observatory in 1912, a whole decade earlier than Hubble, that the universe was expanding. There was a universal expansion, and that if you ran this backwards, the universe began with a so-called, what came to be called a Big Bang, of course, moment, which we now know was 13.8 billion years ago, of course, with this very small, infinitely dense origin story of the universe. Well, Hubble sort of unlocked the key as to what galaxies are, but we really didn't know much about galaxies for a long time thereafter, because as with all sciences, whether it be seashells or minerals or animal bones or galaxies, the first initial long stages of understanding these things is classification, really. And so Hubble was a master of classification, and in the 1930s devised a classification scheme, and he really identified of these then slowly came to be called galaxies rather than nebulae, spiral nebulae. He identified three basic types: spiral galaxies like the one here, NGC 2841, barred spiral galaxies that have a bar, prominent bar throughout their centers from which the spiral arms emanate, and elliptical galaxies that were big spheres of stars without that spiral organization. He had a few other types that he didn't understand terribly well that he knew about, but he really didn't do a lot of work with those. He published his classification scheme in a famous book in 1936 called The Realm of the Nebulae, that's still interesting and valuable to read as astronomical history. Well, later classifications, by the time the late 1950s rolled around, and there was a French-American astronomer who I had the pleasure of knowing toward the end of his life for a while, Gerard de Vaucouleurs. He went to Texas, to Austin, and became a master of galaxies there and devised a much more sophisticated scheme of classification, the so-called cosmic lemon, if you will, that takes into account not only the basic types, but lenticular, lens-shaped galaxies, transition kinds of galaxies, details on the bars in the barred spirals, whether a galaxy showed encircling rings, and how tightly or loosely the spiral arms were wound, and other factors like that. So the de Vaucouleurs galaxy classification scheme is the one that we still use today. By the mid-20th century, astronomers realized that galaxies are the basic building blocks of matter in the universe on a large scale, stars, gas, and dust, mostly. And for many, many years recently, astronomers have believed that, well, how many galaxies are there in the universe? About 100 billion. And we'll get to how they determined that a little bit later here. But that's an approximation of averaging things out over the sky. And a 2016 study by another pal of ours who's in England, Chris Consolis, proposed that, well, maybe there are 1 or possibly even 2 trillion galaxies in the universe. And of course, the rub there is that, as we all know and like to think about, as we look with telescopes at more and more distant objects, telescopes are time machines, and we're looking back in time, of course. And it turns out that the story of galaxy evolution is largely built around small galaxies, proto-galaxies coming together and merging. Because although things are moving apart on large scales, the expansion of the universe, on smaller scales, gravity is at work. And when galaxies are close to each other, brings them together, and they merge and make fewer, bigger galaxies. So we have maybe about 100 billion galaxies in our present day universe, if you will. Well, where do we start with understanding galaxies? At home, the Milky Way. Of course, as most of us know, I think there are many observers who are interested and members of the League and active with their clubs and going out at every opportunity they can under a dark sky. And of course, as we look up into the sky throughout parts of the whole year, but chiefly in the evening skies of winter and summer, we can see that band of light of the Milky Way. It comes from the Roman term Via Lactea, and an earlier Greek term, actually, it was derived from. the Milky Band of light. And that's the unresolved light of some billions of stars in our galaxy's disk seen from within, however. So we're seeing that splay of light across our stars, where most of the stars in our galaxy, in the so-called disk component of our galaxy, are living, if you will. We don't know exactly how many stars are in the Milky Way, because the most abundant stars are dwarfs, are M dwarfs, red dwarfs, and they're hard to see over long distances. But the estimates of how many stars are in our Milky Way galaxy, which is a fairly decent sized spiral, actually barred spiral, we'll get to that story also, galaxy, it's something on the order of about 400 billion stars in our galaxy. Certainly say with confidence, several hundred billion. As I mentioned, the Milky Way is a barred spiral, and we'll talk a little bit in detail about that shortly, but that's something that was a recent discovery. We thought for many decades after the discovery of galaxies that the Milky Way was a normal spiral. Well, it turns out we're in a barred spiral galaxy, and our sun and solar system are about 26,000 light years out from the center of the galaxy, which for living things like us is a good thing, because the centers of galaxies are nasty places, which we will also talk a little bit about. Okay, well, if we look toward the center of the galaxy, we're looking toward the direction more or less of Sagittarius in our sky. For the observers who love that summer Milky Way, if you look between the open cluster M6, draw a line from it to the Lagoon Nebula, from Scorpius to southern Sagittarius, and look at about a midpoint of that line, that's the direction of the center of the Milky Way. But galaxies have so much gas and dust in them that the stuff that, this is an infrared image toward the center of our galaxy here, but what we're seeing with our human eye, our frail human eyes here, or telescopes, of course, we're seeing about a quarter of the way toward the center of our galaxy. We cannot see all the way toward the galactic center because there's so much dust obscuring matter beyond. Our galaxy has a supermassive black hole. We'll talk more also about black holes in a little while and their ubiquitous nature in galaxies. Our black hole in the Milky Way has a mass of about 4.3 million suns. So 4.3 solar masses is about the mass of the black hole in our galaxy. Other dangers that are nasty and might be perilous with travelers through the galaxy or with fragile things like human beings. There's a lot of high energy radiation near the centers of galaxies like the Milky Way. There's antimatter that is bad news, of course, if you're made of matter. There are frequent exploding stars like supernovae and other high energy colliding neutron stars and so on, and other hazards that rise toward the centers of galaxies like the Milky Way. So that is a good thing that we're about halfway out, a little more than that, from the galactic center in the disk. Well, this is a modern shot by our pal Tony Hallis of the Andromeda Galaxy that was taken a few decades after Hubble visited the first time. And of course, like people, galaxies typically like to hang out in groups. Some contain more than others. Our group of galaxies, and it was Hubble who came up with this name in his book, his first major book, The Realm of the Nebulae, he called it the local group of galaxies. A really clever name, but it's stuck and it's our local group. And we know of at least 55 galaxies in the local group. Like faint stars, faint dwarf galaxies are numerous, small dwarf galaxies. We know that many of them have been eaten by their larger galaxies near them. That will probably be eventually the fate of two dwarf galaxies you can see with M31, the Andromeda Galaxy here, little spherical elliptical M32 above it, and NGC 205, which you can see is already, if you can see that faint envelope of gas around NGC 205 below the center of the big galaxy, that's already substantial tidal warping that's going on because M31 is pulling on that little galaxy and will eventually eat it. So there could be as many as 100 galaxies in our local group, but we know of at least 55. The primary members of our local group of galaxies are the Andromeda Galaxy. The Milky Way, we're a little bit smaller than Andromeda, which is a little larger than our galaxy. And then a galaxy that's a prominent galaxy in our fall sky as well. It's a little smaller than the Milky Way, called M33, sometimes called the Triangulum Galaxy or the Pinwheel Galaxy. And those are the three big guys in our local group. All the rest of the galaxies in the local group are much smaller. Speaking of the Triangulum Galaxy, it's a relatively faint object for observers because its light it's fairly bright overall, but it's spread out a good deal. So it has what we call a low surface brightness. It's about 3 million light years away, a little more distant than Andromeda, and it's very active with star formation. And you can see these pinkish so-called H2 regions, these star-forming regions, cosmic clouds, we call them, in the arms of this galaxy, many, many of them here. And the one that's above and to the right of the galaxy's center there is so prominent, it has its own NGC number. It's called NGC 604. And it's one of the two biggest star-forming regions known is in this galaxy M33. So that's impressive formation of new stars going on in one of our galaxy neighbors. Well, funny things can happen in space. As I mentioned, even though things are expanding overall, gravity works on small distance scales. Of course, and so galaxies, especially in groups, especially in rich clusters, even more so, like to come together and merge and make chaotic interacting galaxies. As many of you know, we can see huge numbers of examples of these, even in amateur telescopes in our sky. There's so many of these. So the antennae galaxies here in Corvus are one good example, but there are lots and lots of snapshots in time, if you will, of galaxies that are coming together, doing a cosmic dance, merging, and eventually you can see the chaos in the middle of the disks of these two galaxies. Eventually, these will come together and be one big, more or less spherical object. This is another example. It's NGC 2623, another example of a galaxy that's a little bit farther along in terms of a merger coming together. And we know that our best belief, based on the evidence that we have now, is that the disk of our galaxy, the Milky Way, is about 9 billion years old. And possibly the number of small proto-galaxies that existed way back in cosmic time could have been as many as about 100 of those very small proto-galaxies came together to form a normal large disk galaxy like the Milky Way. We also know that there are galaxies, most of them moving away from us, but some of them are moving toward us. And lo and behold, it's the Andromeda Galaxy itself is one of those, is moving toward us at about 300 kilometers per second. And although that's a very good clip, it's a long way away, as we talked about. So there's a fellow who's the chair, actually, of the Department of Astronomy, who's another good friend at Harvard, whose name is Avi Loeb. You may have heard of him. He likes to write controversial and fun books that get people talking about things, just as Stephen Hawking used to like to do. He ran an experiment, though, with some students of his a number of years ago and showed that in the distant future, about 4 to 5 billion years from now, the Milky Way and Andromeda will merge. And so his playful name for that merger is Milkomeda, will eventually be the large chaotic galaxy that results from our own merger that will happen several billion years from now. Well, as we move farther out into the universe, we can see larger structures of galaxies. Our own local group is about 10 million light years across. our own little group of galaxies. But if we go about 5 times that distance off into space, about 50 million light years, we get to the core, the richest part of the largest group of galaxies near us in our little part of the universe, the Virgo cluster of galaxies. And of course, this is a rich hunting ground for looking at all kinds of galaxies of all types in our spring evening sky. And there are about 1,300 galaxies altogether in the Virgo cluster. The core is actually 54 million light years away from us. And it affords a great playground for looking at all the types of galaxies that exist that are relatively close to us. The Virgo cluster has some of the largest galaxies that we know of in it. The largest one of all is M87. You may have seen the famous picture a little more than a year ago now, a couple years ago maybe, of the first picture of a black hole, if you will. That was the black hole in the center of M87, this galaxy here. If you look really closely, you can see that there's a little tiny bright jet to the upper right of the center of this galaxy. I don't know if you can see that on your screens, but this is a high-end amateur astro image of this galaxy, and that's the jet of material that is falling in toward the black hole and being hyper accelerated, and some of it being shot out rather than captured by the black hole's event horizon. So that's actually the little jet you can see of material being shot outward from the galaxy's black hole, which is much larger than the Milky Way's. This one dwarfs the Milky Way. It's something, it's much larger. It's about 3.5 billion solar masses. So it's something on the order of 1,000 times the mass of the black hole in our galaxy. And this galaxy is enormous. You may say, well, it doesn't sound that enormous. It's about 120,000 light years across. Our Milky Way is 100,000 light years across, our disk. But this galaxy is a sphere. So the volume of material is much greater than a galaxy like the Milky Way, this so-called elliptical galaxy. And it also has a huge family. You see many faint little stars in this image, or what appear to be stars. They're nearly all globular star clusters. The Milky Way, our galaxy, has a couple of hundred of these large balls of very old stars that predate the disk of our galaxy, actually. We have a couple of hundred of those. This galaxy, M87, has 12,000 globular clusters. So the scale of galaxies like this makes the Milky Way look like a very small citizen of the universe. Farther away in the cosmos, there are many more exotic kinds of galaxies that astronomers have encountered over time, mostly the last 30 to 40 years. The faint galaxy in the center of this image, I hope you can see the barred spiral structure there in it. It's a galaxy that is placed exactly in front of a distant, very energetic, very bright quasar, the bright center of a young galaxy that is being lensed by the closer normal galaxy. And you can see 4 images of that quasar being portrayed around the center of the galaxy. This is one of many confirmations of Albert Einstein's theory of general relativity. You don't want to bet against Einstein because his theories win every time. And this is yet more evidence of it. A quasar, we'll talk a little bit more in a moment, but as I say, is the intensely energetic, bright portion, center of a very young galaxy that is emitting enormous amounts of energy. We'll talk more about that in a moment. Well, we talked about how do astronomers really know the numbers of galaxies in the universe. This is one of the so-called Hubble Ultra Deep Field images. There's several series of these Hubble Deep Fields were made. This is the most recent. It's a very tiny portion of the sky, smaller than what your index finger tip would cover in the southern sky, deep southern sky. And you can see a couple of bright stars in this image that have diffraction spikes, but nearly everything in this tiny field is a galaxy. There are 10,000 galaxies in this tiny image. of the universe. And this is how we get the estimate of how many galaxies there are in the universe. You can see in this image, the faintest, bluest galaxies in this field are some of the earliest galaxies as yet known. The Webb telescope may show us younger galaxies yet, but some of these galaxies in this field are only a few 100 million years younger than the Big Bang. And it's these little proto-galaxies that came together to make normal galaxies later in cosmic time. Well, let's talk about quasars. So since the 1960s, astronomers have had a mystery that took about 25 years to begin to really solve. Martin Schmidt at Caltech was minding his own business, looking at very bright radio sources. This is one of them that was in a catalog that was compiled at Cambridge University called 3C273. It was a bright radio source, and he noticed that it corresponded to some very bright optical sources, and he called them quasi-stellar objects, shortened to quasars. This one and 3C48 and some others became sort of poster children. It was clear that these were very, very distant objects, and yet they were very, very bright. They were screaming in parts of the spectrum. So how could that be? This was a mystery early on. And for quite some time, astronomers found an astrophysical zoo up through the mid and late 1980s. They found many of these quasars. They found many so-called BL Lacertae objects named after the prototype there in Lacerta. They found many kinds of high energy galaxies called Seyfert galaxies after the American astronomer Carl Seyfert. And all these sorts of weird, unrelated objects seem to be putting out a huge amount of energy, and the mechanism wasn't really understood until the late 1980s came along, and it became clear that these were all objects with central black holes that were emitting lots of energy because the material falling in toward those black holes was being ejected, some of it outward, and not falling into the black hole. And these were all objects of various types that were being seen from different geometries, but they were all the same kind of object fundamentally. So that was a huge realization in the history of understanding galaxies. Of course, as we know, black holes as a concept go all the way back to the 18th century. John Mitchell, an English natural philosopher, as many scientists were termed at the time, was the fellow who came up with the concept of maybe dark stars could exist that would have such gravitational pull that nothing, not even light, could escape. But it took, of course, until 1975 to have the first good candidate for a black hole. And this was a stellar black hole, a collapsed massive star. And it was, of course, the famous duo of Stephen Hawking and Kip Thorne, who made a famous wager about whether they both believed that this object, Cygnus X1, would turn out to be a black hole, but they bet against each other for fun. And Kip Thorne ultimately won the bet. Stephen Hawking rather meekly bet that if he won the bet that it wasn't a black hole, he wanted a one-year subscription to Popular Mechanics. Well, Kip Thorne wagered that he wanted a one-year subscription to Penthouse magazine. And Kip won the bet in 1990 when it became clear that Cygnus X1 was a black hole, was a collapsed star black hole. So Stephen Hawking bought Kip, his closest friend, a one-year subscription to Penthouse and had it sent there to the California Institute of Technology. Anyway, this whole business of the rarity of black holes got straightened out after the Hubble Space Telescope came along and then got fixed. And a researcher who's another pal, he's still around, he's on Facebook, he's a great galaxy astronomer expert, John Cormandy at Texas. He and his collaborators, Lewis Ho and others, figured out that the Milky Way and that M106 and the Andromeda Galaxy and a whole line of galaxies all had black holes in their centers. And these supermassive black holes started to be discovered one after the other. And now it turns out we know that nearly all galaxies have a black hole in their centers, not dwarf galaxies, they don't have enough mass, but nearly all normal galaxies do. And they're very active when they're young, and there's a lot of material falling into these black holes, and they become quiet as time goes on. And like the Milky Way, there's not a lot of stuff falling into that black hole, so it becomes quiescent and goes to sleep. And that's what most normal galaxies have within them now. And let me just check and see how I'm doing on Terry. How am I doing on time?
You're doing okay. You've got
Still a little bit of time.
got 20 minutes.
Oh, okay. Oh, we're good. Well, maybe we can
Yes.
take a few questions. That's the good part if we get to that. Okay, I didn't want to run over. And once I start, I feel like Abraham Lincoln, said that, there's the preacher who starts to talk, and you get so carried away that, I would have stopped if I didn't realize that it would have taken so much energy to stop, so sometimes I lose track, but so I'll keep going for a little while here. So the mystery of high energy objects and black holes got straightened out eventually by about 1990 and the early 90s with Hubble. And we now know that most all galaxies have black holes in their centers. This is a really active black hole, and you can almost just look at this image. That's an ESO image and just see the chaos going on. This is Perseus A, NGC 1275, and you can see the monstrous black hole is doing some bad things organizationally to this galaxy. And so there's a tremendous upheaval when a galaxy is being fed a lot of material into its black hole, which happens when galaxies merge. Their centers merge, black holes awaken, and star formation goes crazy again, and lots of stuff happens. You can see this incredible disruption that's going on in a galaxy like this. Well, galaxies exist in a sort of a gently balanced state between grace and internal upheaval all the time. And sometimes throughout their lives, they go through crises, and that black hole sort of reawakens, if you will. This is, of course, what's going to happen to us eventually. This is another friend of many of ours in the southern skies, Centaurus A, NGC 5128. This is one of the great southern sky galaxies. And this is the result of a merger. So we can see this as a big elliptical galaxy that's the result of two disk galaxies that merged. And for a long time, the formation mechanism of elliptical galaxies wasn't understood, because how a galaxy gets started is sort of akin to how we understand a solar system forming. You get material that comes in, and the gravity starts angular momentum, and that leads to a disk and motion, and that flattens, and you get good organization. Well, how do you get a big, crazy, disorganized ball of stuff? And long story short, it turns out that ellipticals are believed to be the result of mergers. Centaurus A here that we see is a big mess elliptical, and there's this huge band of dust across it, and you can see star formation in front of that dust band going on from the chaos and reorganization. This is maybe something like the snapshot of what Milkomeda may look like, say, 5 to 6 billion years from now. Well, let's talk just for 1 second, if we can, about another factor that Hubble began to awaken us to, and that is the cosmic distance scale. Many of you have heard, of course, of cosmic inflation, the hypothesis that just after a tiny fraction of a second after the Big Bang, the universe hyperinflated from about the size of a pea to about the size of a grapefruit or a small volleyball. And we won't get into that other than saying that the two different astronomers at nearly the same time in the 1970s came up with this idea, and it explains a lot observationally, believe it or not, of what we see in the current universe today if inflation happened. Most cosmologists believe that it did, but let's set that aside because that's a complicating factor. If inflation happened, and it probably did, that means that the visible universe that we see is not the whole universe. In fact, the universe could be infinite, which sounds like science fiction, but it might not be. But let's set inflation aside, with apologies to Alan Guth and Andre Linde, and say that let's just work with the visible universe that we can see as astronomers. So very conservatively, about 10,000 billion stars exist in the universe, in those 100 billion galaxies. We see planets, of course, abundantly, as we would expect to, as we understand star formation, abundantly around us in the Milky Way with the exoplanet telescopes that are at work now. Okay, let's imagine for one moment, go back and think about the cosmic distance scale for a second. Because if we think about the distance between the sun and Earth as being 1 centimeter, about this size, that's 1 astronomical unit, 93 million miles, more or less. So we've traveled physically as humans a tiny and invisibly small fraction of that 1 centimeter, physically traveled thus far as humans. On that scale, the edge of our solar system, the physical edge, the inner edge of the Oort cloud of comets would be 10 football fields to the right there. And then the closest star to us, Proxima Centauri, would be 4 times more distant than that. So if you're fans of The Hitchhiker's Guide to the Galaxy, Douglas Adams, he said space is really big, really, really big, you know, in his book. And he's absolutely right. That's something that we don't always appreciate, thinking about things and even going out and observing in detail all sorts of things. It's an enormous universe, even the nearest stars to us in our galaxy, let alone distances across the disk of the galaxy or to other galaxies. However, since that early days of astrophysics, since the invention of spectroscopy, we know that chemistry in the universe is uniform everywhere we look. We know that the same slightly greater than 100 number of elements exist, we believe, everywhere, except for a few more we've only created in a lab so far, and they're not stable in the universe normally. We know that each of us, some of us haven't been to the gym enough in the last year and a half, and so this is a little bit different for some of us, but the average, for most of us on average, we have about 7 octillion atoms in our bodies. So that's 7 billion atoms. And we know that those atoms are recycled atoms that make us up, that were created in the deaths of massive stars, in supernovae, in the deaths of low mass stars, of M dwarfs, in so-called Big Bang nucleosynthesis for hydrogen and helium and lithium and deuterium in the early days of the universe, and in merging neutron stars, the collisions of neutron stars for some of the heavy metals, like some that we really think are cool, like gold, silver, and platinum and stuff. So we're, as Carl Sagan used to say, literally made of star stuff. Spectroscopy and chemistry tell us that, well, and the abundance of planets everywhere, local conditions could change, temperatures and pressures anywhere and all over the place. And as we understand it, water is very important for life. Carbon is a very key element for us, for life. It likes to combine with things. Oxygen is important for us. It likes to combine with things. But from what we know about all these things, life should be common throughout the universe. And of course, we only know of one single place, however, in the universe where it exists, right here. So it's amazing what we now know about galaxies and about stars and about life in the universe and about atoms and molecules and star stuff, that we can get together, and we've made enormous strides over the last 10 to 15 years understanding these processes and galaxies And it's a privilege then to be able to come together and talk about this stuff, which Hubble and Newton and even Einstein in some ways couldn't have imagined, together as living beings who came out of these same atoms in the universe. So if we have any time for questions, I'd be happy to take some questions, but otherwise, thank you very, very much.
Yeah, we've got some time for questions.
Excellent. And I will stop sharing my screen now. So with apologies to the Whirlpool Galaxy. Okay.
I am looking at the chat right now.
I have a couple also. Scott,
go ahead. Go ahead, Chuck.
Okay, I have a question here from someone who asked if M32 is possibly the core of a galaxy that's been cannibalized by M31.
And the short answer is yes. And in fact, there are several other massive globular clusters, not dwarf galaxies, but globular clusters that are known to be stripped X-dwarf galaxies, the cores of X-dwarf galaxies. The most famous one is the largest and brightest galaxy globular cluster we know in our sky, Omega Centauri. It's essentially in total agreement now, is the core of a defunct dwarf galaxy. So the answer to M32 is absolutely yes, and that's a great comment and observation.
I had one other, it says, what causes the barring of spirals?
That's not exactly what causes a barred spiral. That's not exactly known precisely. The dynamics of the rotation of a galaxy. We've rotated around the Milky Way about 22 times since the sun was born 4.6 billion years ago. And the angular momentum and the so-called density waves in the rotation of normal spiral galaxies separate star clusters. So our sisters are gone. You know, we were born in an open star cluster, the sun, as all stars essentially are, and scattered. And we don't know exactly what causes the bars to be so long-lived, other than this density wave theory, that the rotational patterns of energy and possibly even magnetism are involved in sustaining those over long time intervals. But that's another very good question. And we don't know everything yet is the problem. You know, we've gained an enormous amount of knowledge in the last 10 to 30 years, but there's still a lot to learn about these things.
Okay, a couple of comments there. We'll start off with a question. Rob Robinson, watching on YouTube, asked, do galaxies have to have a minimum mass to retain their structure?
That's a good question. The short answer is yes, because the galaxies of very small masses, of only a small number of millions of solar masses, tend to be fairly structureless, dwarf irregulars. So they have to be in the some billions of solar mass range to be, we think, to be well-organized galaxies. Now that, again, I would not say is definitively known, but that's where the answer is leaning.
Clearlight 58, watching on Twitch, asks, what can you talk about in the possible discovery of a new arm of the Milky Way?
Well, there's been some talk about that, and the structure of there are two so-called components of the arms. There are arms, and then there's spurs, and those are kind of little mini arms that come off of arms after they've originated away from the bar. And the mapping, I didn't actually talk about this, but the mapping was actually done fairly well only in 2008 by the GLIMPSE experiment on the Spitzer Space Telescope, an infrared space telescope that mapped the arms pretty accurately for the first time. But there's been some recent talk about the structure of the arms, possibly another arm that's hidden by a lot of dust, possibly a more complex structure that we don't understand of our own arm called the Orion arm, that is obscured by a lot of dust as well. So again, that's a developing story, and I think it's too early to say whether this rewrites what's known from the Spitzer experiments that are about a decade old or not.
Okay. Verity from YouTube asks, have we counted galaxies rotating clockwise and anti-clockwise?
Wow, I'm stunned by this. Every time I've given this talk, this question comes up, and I can't believe it, because this is a question that when I was a teenager was one of the first questions about galaxies my father asked me. He was an organic chemist at Miami University in Ohio, and organic chemistry is really keyed into the juxtaposition of molecules, the so-called chirality, whether something is left or right-handed as we see it. Okay, so how many galaxies are wound one way or the other way from our point of view? And the answer, and in fact, Michael West at Lowell Observatory, who's the deputy director for science at Lowell, wrote a story about this in Astronomy 2 or 3 years ago called "Why Do Galaxies Align?" But the answer is not known. And is there an imbalance in the winding of galaxies as we see them? We don't know yet, really. And what would it mean if we did know? We really don't know that either. But that's a great question. Is there significance in the structure of galaxies one way or the other? Is there an analog to the chirality of molecules, which means a huge amount to life getting going here? We don't know the answer to that. But again, I'm amazed that people are thinking about this. It's great stuff.
Mike Overacker on YouTube asks, if globular clusters are old cores of galaxies, what possibly happened to the black holes in those cores?
Okay, that's a good question. And we don't know, we only know of a handful of globular clusters that are believed to be X nuclei of very small dwarf galaxies. Omega Centauri, I said, is one of them. There are a few others, but those would have been the cores of small dwarf galaxies. Dwarf galaxies do not have enough mass to have a central supermassive black hole. But that also brings up the point of, we don't really understand exactly the mechanisms of how globular clusters formed, because some of their stars are some of the oldest stars known in the universe. And as I said, they formed and gravitationally were bound before the disks of most galaxies formed. So why did they come together? And they're out in the halos of galaxies, and they formed before galactic disks did with much younger stars. Nobody knows the answer to that yet either, because some of the globular stars are, 10, 11 billion years old. That's a good fraction of the age of the universe. Great questions again.
David McCallie says, why do some galaxies manage to attract each other by gravity, but others expand away? Is it just random proximity?
It is proximity. It's gravity, which likes to work absolutely the same way everywhere. So mass inherently has gravity, of course, attached to it, but there are also local motions going on. So some things, if you look at the Whirlpool galaxy, M51 in Canis Venatici, its little guy, NGC 5195, the little interacting galaxy that's drawing material off of one of its spiral arms, that makes a really bright, good interacting pair example. It's moving at a fairly good clip, that little galaxy, and may pass it right by and draw material off of one of its arms and not become a full merger, because the velocity is significant enough that it's overcoming gravity. So there are examples of all that stuff happening, but we didn't look at the core of a rich cluster like the Hercules cluster of galaxies or others like that, the Coma cluster. In dense, rich environments where they're so-called CD, centrally dominant, big, supermassive elliptical galaxies, there things are close enough that the galaxies mostly won't escape the gravity of those big guys.
I have a question from someone here asking, are the Magellanic Clouds bound to the Milky Way or are they passing?
The Magellanic Clouds are bound to the Milky Way, and I don't think the time scale is known exactly precisely well, but it's very likely that both of them will eventually be victims of ours. Now, there's it's known that quite a number of dwarfs have been consumed by the Milky Way in the past, and the Sagittarius dwarf elliptical galaxy is one that's currently, there's a nice star stream attached to that galaxy, and it's currently on its way to being the next galaxy that we consume. But I think the overall belief, and this goes from Paul Hodge right on down the historical trail, I think, is that both Magellanic Clouds eventually will become part of us.
If I may, I've got one more here asking, I saw a diagram of something called the Canis Major Dwarf that looked like it was intertwined with the Milky Way in loops. How was that detected?
That's a good question. And a lot of this is infrared astronomy because there's so much dust. And there could be, as I say, quite a number of dwarf galaxies that are directly behind our disk on the other side that we don't know of at all. So that's, again, one of these many dwarfs that there are, gosh, I don't remember the precise number offhand, but there are something like a dozen and a half dwarfs that are bound to the Milky Way, at least loosely. And that's one of them, and eventually will be gobbled up as well, probably. But it's got to be infrared astronomy that gives us our best look at the orbital dynamics of those, because most of them happen to be obscured.
Sure.
All right. That was fantastic, Dave. Thank you. We're going to need to wrap this part up. Really interesting. I look forward. I'm going to have your book. That was very interesting.
Thanks so much, Terry, and thanks and good luck to everyone. Thank you so much for having me, and rock on, Astronomical League. Love it.
Thanks. Thank you, David.
Thank you, David.
Thank you.
All right, Chuck, are you ready to do some door prizes?
I guess we ought to give away some stuff, yes.
Yeah.
Okay. First of all, Jim Fordyce, are you here with us?
Yes, I am.
Welcome. I don't know how much of this is public, but is Dee doing all right?
Dee is doing okay. He's in rehab now, still paralyzed on the left side, no vision from his left eye, but we got our fingers crossed and hope that he is able to regain a lot of what he has lost.
Well, we're sure thinking about him.
Yeah.
Jim is president of the Albuquerque, hold on, I don't want to misname anything, Albuquerque Astronomical Society, which will be hosting our convention in 2021. They were supposed to host our convention, I'm getting the years mixed up. They were going to host it in 2020, and that got canceled because of COVID. Then we're supposed to host it this year, and have been kind enough to, again, accept the mantle of hosting our convention in 2022. So we really thank you, Jim, for putting up with us during this pandemic and being willing to continue working with us on hosting our convention next year. We're sure looking forward to being there.
We sure are looking forward to it as well.
Okay. I'm seeing your image frozen right now, but we can hear your voice.
Okay, let me go ahead and share my slide here.
Oh, that's probably what was causing it. Go ahead.
Yeah, let me get that going. Did that do it?
Yes.
Okay, so talk just a little bit about 2022 ALCon. The dates for the ALCon will be 28 to 30 July next year. It'll be at the Embassy Suites Hotel here in Albuquerque. We will be the host club, the Albuquerque Astronomical Society. We're a fairly large club. We've got 492 members the last time I checked. And we actually hosted the 1962 ALCon. I've got a copy of what I think is the original magazine article that covered that ALCon that we'll have on display there during the 2022 ALCon. So it's 60 years later. Some of the events that we'll have will be a welcoming reception. There'll be a historical astronomical exhibit. We will have, of course, a vendor expo. We'll have spectroscopy, astrophotography, and photometry workshops. There'll be 13 speaker sessions and a panel discussion that will be led by the Astronomical League president. A very special event will be the astronaut Harrison Schmitt, who flew on Apollo 17 and is a Albuquerque resident. He will be giving a dinner, and you'll be able to meet him at a private session before that dinner. There will be an awards banquet, of course. We will have several star parties, a couple down at our observatory about 50 miles south of Albuquerque, and another at Aurora, which is a national wildlife refuge, which has been designated by the International Dark Sky Association as the first urban dark sky place.
Jim, I'm not seeing individual slides here.
Oh, I thought it was being shared.
Terry, do you see them?
No, I can see the screen, but I do not
Yeah,
see.
it's just, it looks like our schedule.
Oh, okay. Hold on a second. Let me see.
I'm sorry, I should have mentioned it earlier, Jim. Take your time.
Yeah, let me stop what it is I'm sharing and reselect it.
There you go.
Yeah.
Okay, is that showing
Yeah,
scheduled events?
Yes, we can see it.
Great. Okay, well, now we're back in business. Zoom did us in. So I was on talking about star parties. So we'll have several of those. And we'll be especially bringing up the Valle de Oro National Wildlife Refuge, which is the first urban dark sky place designated by the IDA. It's just south on the south side of the Albuquerque metropolitan area. And then finally, we had a very nice talk earlier today by a couple of representatives from down in Socorro and the NRAO about the Very Large Array. On the day after the ALCon ends, we will have a tour going down to VLA. We purposely put it on the day after the ALCon so that a lot of people that need to be there to do the ALCon itself can also go to the VLA. Just some brief information about registration and lodging. We will have a website up. It should be up sometime in January next year. There's the URL for it. Our expected registration fees will be $90 for individuals, $135 for couples, and $45 for student and youth. For the Embassy Suites Hotel, all the rooms are 2-room suites. If you've ever been to an Embassy Suites Hotel, they're very nice. The lodging rate will be $129 a night for either a single or a double. If you have any questions at all, please contact me. There's a email address that you can use. If you just go to task.org, you can also find information on how to send that same email. And then finally, the door prize that we're offering tonight is $150 towards a room at the Embassy Suites Hotel during ALCon 2022.
Fantastic. Jim, please express to your members our appreciation for all you've done to try to keep this convention alive for so long. I know that's frustrating for your committee, but we really appreciate it. It means a lot, and we can't wait to come to New Mexico. Let's draw a number, Terry.
Okay.
I'll share screen and go to the number generator. You ready?
Yep.
It'll be number 22.
22. That'll be fairly easy. It is William Brakelet.
Brakelet, okay.
Brakelet.
All right, congratulations. We look forward to seeing you in Albuquerque. And Jim, thanks again, and give our best to Dee, will you?
We sure will. Thank you very much.
Okay, thank you. And let's see, Brian Risley, are you here with us, sir? Let me stop sharing.
Yes, I am.
There you are. Okay, you're with the Southwest Florida Astronomical Society. And the Southwest Florida Astronomical Society has very generously offered a $250 gift certificate to Opt. And that's extremely generous, and we sure appreciate it. Would you like to tell us a little about the prize in your club, please?
Okay, well, the
Let me go ahead
prize
and draw the, excuse me, let me draw the number first to give Terry a fair shot. I'm sorry to interrupt you.
it's okay.
Okay, here we go. 294, Terry.
294. Okay, got it.
Okay, I'm sorry. Go ahead, Brian.
The door prize is the $250 gift certificate. The little bit of information about our club. We were established in 1980 at the Edison Community College by astronomy students and educators, both taking credit courses there, as well as they had some general public courses for all ages. And that was our founding there. In the 80s, we started meeting at the Junior League Museum and Nature Center in Fort Myers. And then in 1986, they opened the planetarium there, and we've been involved with them there ever since. It has gone through a renaming. It's now called the Clusa Nature Center and Planetarium. This is a little shot of the planetarium with a special visitor from the Astronomical League who came down and met with us. Members volunteered at the observatory at ECC through the 80s. I was involved in the late 70s, early 80s there. Florida Gulf Coast University came to town and they opened the Egan Observatory, and some of the members were actively involved in programs out there. ECC closed down the Fort Myers Observatory and moved all equipment to a new Moore Observatory up in Punta Gorda, and our members now run the public observing and maintain the equipment there at the Moore Observatory. And we've had an ongoing relationship with the Foundation for Lee County Schools and the Edison Festival, Fantastic Day of Discovery, which is a huge event. Thousands of kids and adults come out to this event. They've got all sorts of science, engineering, math type programs going on. Local government wise, we work with the City of Cape Coral, Lee County Parks and Rec, and City of Fort Myers Parks and Rec, holding events out at their parks and doing special events. And a big one we do is the annual Burrowing Owl Festival with the City of Cape Coral. And we set up solar observing, and we literally have thousands of people come out there for it. It's one of the big local events in town. We've been working now with the National Park Service for quite a number of years. Big Cypress Preserve, which is an IDA dark sky park, holds seasonal star parties. And literally we get out in the middle of nowhere, 300 to 400 people. A lot of the groups from South Florida come out, set up the telescopes for the observing with them. Big Cypress hosted one of the Dark Sky Park Ranger training programs, and we were down there helping them with handout materials and other resources. Ding Darling on Sanibel holds an annual Ding Darling Days event that we set up our normal solar observing type stuff. Again, 1,000 people is a small crowd. And we go meet informally at Big Cypress for imaging and dark sky sessions. For those of you who might be freezing eyeballs to scopes, come on down in the winter. It's nice and warm and very beautiful skies down there. This is the observing field at Big Cypress. And this is Ding Darling with a setup for solar observing. We do a lot of outreach when we can. We work with the regional Cub Scouts. They have an annual Cub Scout extravaganza where from like a 4 or 5 county region, they have all the Cub Scouts come out. And the Girl Scouts have a local camp that we do programs at. And the Cape Coral Kiwanis have a fall festival that, again, we've done a number of years with them. We have a group of people that up in the Charlotte County, Punta Gorda area that took it upon themselves to go out and start doing solar observing 1 weekend a month at different parks in the county. And they've been doing that now for about 5 years and all. And we've have a community down here that is being developed called Babcock Ranch. It's a big solar energy community that are environmentally aware, and we've done several star parties with them out there. And basically, what do we do at a solar event? We have both the hydrogen alpha and white light solar telescopes. We've got a variety of displays that we set up, and we print and supply handouts from AL, IDA, Night Sky Network, Sky Maps, and others. I go through 3 or 4 boxes of paper a season for all these handouts. So we try to get the information out to people, and that's what we do.
Well, that's fantastic. And let me get you to stop sharing for just a moment, if I may. And I would just like to point out to our audience that this is what one club does. You heard him talking about thousands of people contacted by one society. So you can imagine the importance that league member and even non-league member societies fulfill all across the country in terms of public education, simply something that the professional astronomy community is not big enough to do, which is why a very significant professional astronomer, Harlow Shapley, was our first interim president of the Astronomical League, because he recognized way back in the 1940s the importance of amateur astronomy. So Terry, who won the $250 gift certificate being offered by the Southwest Florida Astronomical Society?
Mary Christopher will be enjoying that gift certificate.
Okay. Congratulations, Mary.
Congrats.
And do we have, thank you very much. Appreciate it. Brian,
Yes,
take
thank
care.
you.
Do we have a representative from the Charlottesville Astronomical Society with us?
Yes, Chuck, we do. Hi, how's everybody doing this evening?
Mark, how are you tonight?
I'm good, thank you.
Let's go ahead and draw a number first, and then I'll turn it over to you. Give me 1 second. There we go. Okay, Terry, you ready?
Yep,
713.
got it.
Okay, Mark, why don't you tell us a little bit about your club and the prize you're offering?
Sure, happy to. So the Charlottesville Astronomical Society has been around for a number of years. We're very active here in the Charlottesville, Virginia area, and we're very fortunate enough to be loosely affiliated with the University of Virginia. That operates 2 separate observatories, one here in the middle of Charlottesville and one about 15 miles outside of town, slightly darker skies. The McCormick Observatory, which you see pictured there on the screen, has some interesting distinctions. For example, when it was first opened back on Thomas Jefferson's birthday a number of years ago, it housed the 2nd largest telescope in the world. Granted, that was in 1885. And it's no longer the 2nd largest telescope, of course. It's a 26-inch refractor. But we're fortunate enough that, at least in a non-COVID world, we're able to hold our monthly meetings there in the observatory and have access to not only the big refractor, but they also have multiple other telescopes housed there that we have access to. And also at the Fan Mountain Observatory, where they have at least 4 different scopes there, ranging from a 40-inch reflector to a 24-inch rapid response robotic telescope. So a wide variety of viewing opportunities there. And of course, a lot of that is made available to the university's astronomy department for PhD candidates and grad students and what have you. And they work very closely with us. We're, I think, probably a relatively small club. Certainly for the opportunities we're able to provide, I think we are able to do a lot for our size. As of the end of July, we were right at 100 members. Many of which are very active in observing and in particular in outreach programs. We tend to focus a lot on outreach, both within the community and within the surrounding areas. Some directly sponsored by the club, some more loosely affiliated with the club. We get involved in places like Skyline Drive up in the mountains on the Blue Ridge, where we've got some really beautiful dark skies and some great viewing opportunities there. We also have what we call the Future Astronomers Club, which is a subset of our group that focuses on children and introducing children to observing and to astronomy. And as they go through the program, we give them a set of binoculars, lots of training materials and educational materials, and ultimately we provide them with a telescope. So that's something we're very, very proud of and very excited to be able to do for the youth in the community. And like I said, just lots and lots of outreach programs. So the door prize that we're offering this year is a 2-year membership in what we call the Friends of Meander McCormick Observatory, which normally if you were purchasing this, of course, you would be supporting the observatory and all of the things that it does. But by being a member of this, you get lots of invitations to events. And we certainly hope that those are going to be picking back up this fall as the university opens up for the fall session and certainly going into next year as well. But there's lots of what they call public nights where they're invitation only to members, where you can come in, use the scope, see what's going on, see presentations. There is guaranteed admission to a couple of different annual events that happen at both Fan Mountain and McCormick, and a newsletter with some interesting things going on. Lots of lectures that are certainly very informative. The university has access to all sorts of wonderful folks from literally all over the world that they bring in for exhibits, lectures, and what have you. And there's even a nice little, relatively small, but a nice little museum there in the observatory with some neat looking equipment going back many, many years, even to the late 1800s.
Okay, it's a beautiful telescope.
Yeah, it's really impressive. You've actually got to climb on the left of it there. You see a little ladder, and you've actually got to climb up the ladder to get to the eyepiece. It's an interesting setup.
Yerke style ladder.
Yeah, exactly.
Exactly. Okay, can I get you to stop sharing at this point? And Terry, do we have a winner for this prize?
Yes, we do. Lorraine Hart.
Okay, Lorraine, congratulations on that. And Mark, really appreciate your being here with us, and your club looks like a fabulous organization. Congratulations.
Thank you, Chuck. We certainly enjoy it, and thank you for having us.
Great, thank you. Take care. Okay, let's see here. Is Bob Garfinkel with us? Okay, this was a late prize edition, so we may have to delay that to another session. We'll hold off on
why
that.
don't we do that?
Yeah.
Because there was some confusion. He was lately notified.
Okay, Tyler Westring, are you with us?
Yes, I am.
Hello, Tyler.
Hi, how's it going?
Pretty good.
That's good.
It is my pleasure to introduce to you a winner of our Horkheimer Smith Award this year. This is our highest award for service. It is sponsored by the Horkheimer Charitable Foundation. And Dwight Horkheimer has been so generous to the league in sponsoring all of our Horkheimer awards. And Tyler, you can hold up that plaque if you like. That is the plaque for the Horkheimer Smith Award. That's our highest award. You'll notice it's combining the names of Smith and Daria. And that's because we had a tie for first place this year, despite 4 judges, dead tie, and Tyler and the other individual, Connell Richards, will both receive the full first prize of $1,750 from the Horkheimer Foundation. And I'd like to tell you a little bit about the things Tyler has done, and it will exhaust me to do so. He is a rising homeschool senior in Roselle, Illinois. He is vice president of observing for the Northwest Suburban Astronomers. I think that's an organization of about 150 members, a number of whom have been added to the club through his efforts. He, as vice president of observing, is responsible for all of the weekly events of the organization. He writes the monthly observing article for the Celestial Log, which is the club's newsletter. He works with libraries and schools in the area to set up public observations. He has handled the club's COVID-19 restrictions, trying to set up observations that meet all of the COVID-19 restrictions that the club has decided upon in terms of numbers and distance. He has staffed deep sky observing and telescope exhibits at Astronomy Day events in 2018 and 19, and in 2020 conducted a virtual Astronomy Day event. He runs the club's Twitter and Instagram accounts, and those have generated a number of new members for the club. He hosts a YouTube channel for the club and the Planets newsletter, or Planets. What is the name? Planets?
It's called Planets Videos.
Planets
That's my
Videos,
YouTube
yeah.
channel. Yeah. Yeah.
Which has attracted 22,000 views and 300 subscribers so far. And as if that's not enough, he also does live stream programs and publishes the Planets newsletter. So he stays really busy. And Tyler, people like you are what make astronomy roll these days. And congratulations to you on the award. What are your plans?
Sorry?
What are your plans?
So my plans now, basically I'm wanting to become a park ranger. So I'm going to go to University of Montana and study there. And I want to get into, park education for like night skies and stuff, because the National Park Service has a very good program for the night skies and everything. And I'd love to get into the interpretive side of that. And so, yeah, that's what my plan is right now. I'm looking into University of Montana. So
fantastic. How'd you get into astronomy?
So I got into astronomy. I've had so my brother was actually into meteorology. And so he was looking at the sky a lot. And so I thought maybe to start by looking above him and what he looked at. And also I went to a star party. It was in the suburbs. And I looked at the Ring Nebula for the first time through a Schmidt-Cassegrain, and that blew my mind. I mean, even the Ring Nebula from a suburban sky just blows you away, with high magnification. And that's really what hooked me. And that was about 6 or 7. So
that's fantastic. Well, again, congratulations. You'll be receiving a letter from President Carol Orge here very shortly with a nice check with it. And hope you put it to good use, and good luck at the University of Montana.
Thank you so much.
Okay. Thank you, Tyler.
Thank you.
Okay, Terry, it's all yours.
All mine, huh? Well, it looks like it's break time. So.
Perfect timing.
Yeah, definitely so. Let's take a quick few minutes. How many minutes we got?
10 minutes.
Yeah, I got 10 minutes. We got a 10-minute break, and we will be back with Alan Dyer. So we'll see you in a few.
Oh, there he is. Maynard, how are you doing?
I'm
Earth
doing
to
pretty
Maynard.
good.
Earth to Maynard, are you awake?
Yes, I had to unmute myself so everybody wouldn't yell at me. You're muted, you're muted. So yeah, I'm doing pretty good, Ron. How you doing?
I'm hanging in there. I'm hanging
glad
in
to
there.
hear it.
Yeah, I've got dialysis tomorrow, so I'll be running a little late. But other than that, I'm hanging, just waiting on that damn kidney. The good news is the doctor report I got said for 72 years old, I have the body of a 55-year-old, except my kidneys are shot. Everything else, all the blood work, all the numbers, all the organs are right where they're supposed to be.
Well, that's good. That's good.
Yeah, so I told him I plan to live to be 140, and I'm only halfway there, and he left.
Okay. I set the bar low. I was thinking about 109 for myself.
Oh, yeah, you said it real low. But you live in Florida. You see, I live in New Mexico where, people live longer.
That's right. People are already old by the time they get here, old and worn out.
Well, you've got all that humidity out there, which, when it rains, we have 4%, that I think helps.
You ever work on your stamp collection?
Yeah, I'm in the process of divesting some of it, the stuff I don't want. I got a guy coming over, in fact, in 2 weeks, and he's hopefully going to have a big truck and a big check and take a lot of it. But then I still have my personal collection, and I figure when I die, the wife's going to get that, and she'll know what to do with it. I've already left instructions.
Well,
hey, all right. I got to jump in here because you mentioned stamp collecting. So you both are stamp collectors?
No, I am. Oh, are you a collector, Maynard?
So Maynard's just socializing? Or are you a collector, Maynard?
I am a collector. I have a stamp collection and a stamp accumulation. And I've been trying to get my accumulations out of here for a while.
Okay, well, I have a collection. I've been collecting since I was about 6.
Yeah.
And when my natural father died, I wound up getting his collection, which was Israel complete up to the day he died. And that included the tabs of 1 through 7, which are the only money stamps in all of Israel. Then I've traveled the world. And so whenever I traveled, I'd go to various stamp shops, and I did a little history. So for example, when I was in Germany, they hated France. So they wanted to get rid of all their French stamps. So I bought all their French stamps for a good price. And then when I went to France, they hated Germany. And I was able to get all the German stamps I wanted at a really good price. So my France, my Germany, my Taiwan, my China, my Singapore, my Thailand, Belgium are virtually complete. I mean,
Wow.
virtually. The only ones I'm missing, like in France, are those $400,000 stamps. I only have one each of those. I mean, so,
Yeah. Now, Aaron, you're a collector too, aren't you?
Yeah, I collect stamps, but my scope is much smaller than yours, Ron. I collect mint US stamps only.
Oh, I'm sorry.
I'm not.
No, they're fun. They're getting better finally.
Yeah.
They were boring back in the 30s and 40s when they were either purple or red.
Well, now I think they're doing it just to make money off of us stamp collectors, so I'm not impressed.
Yeah, exactly. I agree with you.
I thought those stamps back in the 30s, like the National Park Series and stuff like that, were really beautiful stamps.
They really are.
Were. They're absolutely
pretty
gorgeous.
Yeah, I used to collect the US mints also.
Okay.
Now I'm doing coins instead.
Ah, okay.
Yeah, I collect those old classics, and the artwork on those old stamps are just outstanding.
Well, they were all engraved. The stuff
Yes.
they do today is lithographed or
Yeah.
printed. And yeah, there are a few relatively new engraved stamps. They did one about 20 years ago, which is relatively new. What the heck is it? Can't remember. The mind is slipping.
Well, you just said
Lewis
it was
and
only
Clark.
20 years ago.
Oh, shut up. The Lewis and Clark expedition.
Yeah.
They were real pretty. They did a very nice job on those. But
I'm a member of the Sons of the American Revolution, and we had an interesting speaker talk about the old bicentennial stamp series. And he's on the council, the board that approves all these new issues. It's fascinating to meet someone who's in that process.
Yeah. I used to be a dealer. I had a company after I retired from Philips and before I moved out here. And I did pretty good with that. And I sold that off, and then I moved out to New Mexico. I was living in the Carolinas at the time. But no, stamp collecting is a lot of fun. It made me the man I am today. It keeps my mind moderately sharp, or as sharp as I can be.
I think I'm going to get back into stamp collecting. I'm planning on selling my coin collection.
Really?
And switch back to I like stamps. I've always
They're
liked
fun.
stamps better than the coins.
Well, if you're looking for anything in particular, I'm sure Maynard's got some he wants to divest. I've got some I'm looking to divest. So just tell us what you want, and I'm sure between the two of us, we can find something.
Yeah.
You should have put in a bid on that British Guyana 1 cent magenta there, Ron.
No, I didn't. But I do have, if you follow it at all, China 999A, the only mint never hinged plate block of 4 known to exist.
Wow.
Nice.
What it is.
Those are some very, it's the most expensive thing I own.
I got to see the 1 cent magenta at the U.S. Postal Museum in 2019.
Did you?
But it's been sold now to somebody in the Middle East, I think.
Yeah, somewhere for, I don't know, for 6 million or something.
Under what they expected. It came in under what they expected.
Yeah.
Oh, darn. I should have bought it.
It
Really, it was a bargain.
Hey,
I would have. Had I known that, I would have bought 2.
Aaron, so I'm logged in. Is this the practice session for?
No.
We're live.
We're live.
We're live. Okay, but this is how I get in tomorrow night to do
You're doing fine.
So 3-minute door prize thing?
Correct.
Okay, that's basically what I wanted to know.
Okay.
All right, great.
Yeah, in 2 minutes and 33 seconds, we'll be back on the air.
Yeah, well, I think
All
we're on the air now, actually.
Oh, are we? Oh,
Yeah.
my goodness.
So people
All right.
are listening to our gibberish?
That's
No, they
correct.
aren't. Are they really?
But at least it's interesting gibberish, thanks to Ron.
You see the little word that says live up there in the upper left corner?
Oh, yeah.
Oh,
You.
whoops.
Right.
All right. I better
Right.
mute then.
I'm gonna check in tomorrow night then, guys.
Okay, Doug. Good to see you again.
Well, I will say this. I think the future of our hobby of astronomy is prospering. I'm concerned about stamp collecting.
Oh, it's certainly brighter than stamp collecting, yes. But let's get serious. It's called philately.
Yeah, but since
Yes.
we're live, I'm a preacher. I didn't want someone to misconstrue what I was saying.
Oh, what are you? What's the matter? You're not a fatalistic philatelist?
Oh, yes, I think I probably am.
I think we all are.
Well, it's a great hobby, but my wife says I only have one hobby, and that is collecting hobbies.
Mm.
Yeah.
Well,
I can relate.
My
Yeah.
wife wished I had one hobby, and that was her. Afraid not. I've got too many other hobbies.
Maynard posted a cartoon once, and the first caption was, "You said no more telescopes." And the husband responded, "No." I said no, more telescopes, or something like that. Can't have too many.
Well, I will say I'm reducing the number of my telescopes. We're getting ready to move, and so I'm divesting myself of a lot of telescopes.
Well,
A person doesn't need a half a dozen to actually 16 telescopes.
If you decide to divest the Questar, let me know.
No.
I didn't
That'll
think
be the
so.
last to go.
I did not think so.
You know, the older I get and the stronger gravity gets, the more I use that thing.
Yeah,
I've had it
I hear you.
over 50 years.
By the way, Terry is back, so we have to stop talking about her.
Okay.
Terry's been here the whole time.
Oh, okay. Sorry. I know. There we go. Here we go.
Okay, can you hear me?
Yep.
Okay, welcome back, everyone. This is session 4, the final session of our Thursday programming for ALCon 21 Virtual. And just briefly to tell you what we have coming up, we will have a speaker in a moment, Dyer, speaking on chasing the Northern Lights. We will have some awards and also a brief presentation about our 2020 National Young Astronomer Award winner. And then we'll have our library telescope program and giveaway. As you know, the League gives away 11 library telescopes to one club in each of the 10 regions, plus a member at large. And then we'll have some more door prizes to conclude the evening. And so at this point, I'll turn things over to Terry Mann to introduce our speaker.
Thank you, Chuck. It is with great pleasure that I will introduce Dyer. He will be speaking, as Chuck said, about chasing the Northern Lights, something that is one of my favorite things to do. Is the co-author of Backyard Astronomer's Guide, and they have a revised and updated version coming out, 4th edition coming out very soon. He is also the author of the ebook, How to Photograph and Process Nightscapes and Time Lapses. That's in Volume 1 and Volume 2. He lives in Alberta, Canada, where the Northern Lights probably, you see a lot more of the Northern Lights than I do, but that has to be a beautiful area. And he also has an asteroid named after him. It's asteroid 78434, named Dyer. So Alan, with great pleasure, please take it over.
Turn your microphone on, Alan. There you go.
The presentation I sent was pre-recorded. Someone's supposed to be feeding that
That's right.
video file into the feed.
Hello, Scott.
My
I
connection
can
is
do
not
that
good
right
enough
now
to-
if you'd like.
Yes, please do. You should have the file and just feed it in.
I do. It's all queued up.
All
and
right,
everything.
sorry.
We just thought you wanted to say a few words before.
Oh, no.
No.
Well, I am here live, but I didn't want to risk doing a live presentation because my rural internet is rather slow and it can choke and so I don't want to risk that for an important event like this. So that's why you've got the video file.
All
It's an hour talk. And if there's time at the end, I can come in for questions, Q&A, but I didn't want to, I'm just here live just to get things going and then roll the tape.
Okay, here we
Thanks,
go.
Alan.
Well, good evening, and thank you for the invitation to speak this year at ALCon, the virtual version of ALCon. It's my pleasure to be here. My name's Alan Dyer, and I am going to take you on a chase of the Northern Lights up to the northern part of the continent to see the Northern Lights, or in this case, to my backyard as well. I'm very fortunate in living in southern Alberta, where I can see the Northern Lights fairly often, right from my backyard. Most people would kill for a display like this and consider this a great success. This was a display back in April or so. We see them fairly often here from Western Canada, the Aurora Borealis or the Northern Lights as well. But again, if you want to see them yourself, you often really have to chase them. You have to go. You can't wait for the Aurora to come to you. It can happen. And so you have to go to a location to see them. I'll talk about where to go, when to go, the best time, what causes the Northern Lights. It isn't necessarily what you might think. How to know when to look, even when you're on site. What to see, the colors and what produces the colors and what you can see in the way of those colors. And how to capture the lights for yourself. It's fairly easy to do. And then we'll finish off by talking about Steve. If you don't know what Steve is, we'll stick around. We'll talk about the Aurora named Steve. So that's the agenda this evening. We'll start off by talking about where to go to see the Northern Lights. It's like a total eclipse of the sun. And when the Aurora gets really great, I rank it right up there with a total eclipse of the sun for spectacle, for a bucket list item you must see. As I said, I'm very fortunate and I can see the Northern Lights fairly often, as we can here from southern part of Western Canada. This is from a lake just a half an hour drive east of me in the summer with the noctilucent clouds visible low in the north there as well, reflected on the water. And so we can see them from time to time here quite well, usually across the north. However, if you want to chase the Northern Lights, if you want to have a trip dedicated to seeing the Aurora Borealis, you need to go to a location somewhere along that blue oval. The Aurora Oval, where the Aurora is most active, most frequent, and most likely to produce a great display, kind of on demand, as it were, during a trip. It's an oval centered on the North Geomagnetic Pole, which sits up in the high Arctic islands of Canada. Now, my home in southern Alberta, I often see the Aurora, as in the previous few pictures, to the north. I see that auroral oval. It still has to get reasonably active, but I see it to the north as this arc across the north with varying levels of activity and colors as well. It does come down over me. It will over the United States from time to time when it gets very active, which we'll talk about. But the Aurora is almost always present at some level of visibility and activity along that auroral oval. Locations like Norway and northern Scandinavia, Churchill, Manitoba, and Yellowknife, Northwest Territories. Those are locations I have chased the Aurora to. Hope to again once the travel opens up again. And I'll show you some pictures from those locations as well. So those are choice spots which do cater to Aurora tourists. It's a fairly major industry. In Churchill, Manitoba, for example, they're famous for polar bear tourism in October, November, and the polar bears are migrating and moving out onto the Hudson's Bay ice. But the Aurora season has become second only to the polar bear season for tourist attractions and tourist visits in Churchill. Yellowknife, all kinds of hotels being built to cater to Aurora tourists as well. Been quiet in the last year, but that will pick up again, we hope. Now, places I have not been to, but you might wish to visit. As Americans, you want to stay in the United States. Alaska is a prime destination for Aurora tourists as well, or Fairbanks typically as well. Iceland is the other location that's very favored. They really cater to getting North Americans over with cheap flights as well. And lots of people go there, fabulous scenery, but you really have to have patience because it can be very cloudy a lot from what I understand from friends who have been there. You could be there for a week's tour and maybe get a clear night and a glimpse of the Aurora as well. But the scenery is fabulous, as it is in Norway and Alaska as well. So those are the kind of key locations that you want to plan trips to, I think, in order to be more assured of getting a good view of the Northern Lights. For example, here's a view of the Auroral Oval, that arc of Aurora across the north. There's the Big Dipper from Norway, from the coast of Norway. I, for the last few years, until the shutdown, was an enrichment lecturer on board Hurtigruten ferry ships, which ply the Norwegian coast from Bergen to Kirkenes and back again. It's a fabulous trip, a wonderful scenery. You're above the Arctic Circle for about half that time, underneath the Auroral Oval, and again, in sort of late autumn into early winter. We'll talk about the best time to go in just a moment. So it's a great spot. Again, the scenery, even if it's cloudy, the scenery along the coast is incredible along the Norwegian coast. So over in Europe, it's Norway, northern Scandinavia, Finland, and Sweden as well. But in North America, here's the Auroral Oval, the actual Aurora, on one night here, taken from one of the orbiting NOAA satellites, looking down and seeing the actual oval across North America here. On the lower left is a little blip to the east of Calgary is where I live, or the arrow pointing to my location. But above that, to the top left, is a little blip of light on the shore of Great Slave Lake. That's Yellowknife. And a tinier blip of light, a small community, Churchill, on the shore of Hudson's Bay is Churchill, Manitoba. And so they would have seen the Aurora a little to the south of them that night, but they're usually underneath the Auroral Oval. And this night I might have seen it to the north of me, but you can see it's still well north of the United States. Now, here's the Auroral Oval from Churchill, Manitoba. It's a broad arc across the sky, probably earlier on in the evening before it really developed. And there it is across the northern sky in a sort of almost 360-degree panorama. From the Northern Study Center, we go to Churchill and we take tourists to this research center, research station, studies Arctic, all kinds of aspects of the Arctic environment, and caters in the wintertime to Aurora tourists. A great spot to go, nice and dark. We turn the building lights off at night, and we have the place to ourselves. It's a wonderful spot in Churchill. And Yellowknife is another location I go to fairly frequently. Not last year, maybe this year. We'll see if the travel restrictions open up. The northern communities have been very tight in terms of letting people in, as they should. As well. But here's the Auroral Arc, all the way across the sky from Yellowknife in the Northwest Territories. Really only about a 2 or 3 hour flight north of me from Calgary, or flights from Vancouver as well. And this is from a downtown park, Rotary Park, in just a couple blocks from downtown Yellowknife as well. Fabulous city to go to for Aurora. There it is on the shore of Great Slave Lake. Now, to judge when you're going to see Aurora, it's this KP index, which is kind of the key factor. Not the only one, but kind of the key factor people watch. Now, this is an interesting map produced by Chris Ratzlaff with the Alberta Aurora Chases Facebook group. I'll introduce Chris at the end of the talk. But it's a nice map that he prepared that shows you where the Aurora, the southern limit of visibility of the Aurora, is going to be at these various KP levels. There can be a KP 0, but typically it's KP 1 is kind of your baseline that the Aurora is always at. And so locations in central Manitoba, northern Alberta, and the like are seeing Aurora on the horizon. This is just seeing the Aurora on the horizon. Might be just a diffuse glow at KP1. KP2, it's moved further south. Saskatoon and Edmonton are seeing it, perhaps just as a fairly nondescript glow along the horizon. At KP3, Winnipeg, Regina, and Calgary, now where I am, east of Calgary, is seeing the aurora on the horizon, similar to what I showed in the earlier pictures, although I think it was more like KP4 in those pictures, where it's more active further south and it's going into this yellow alert stage. And so now the northern states are just beginning to see aurora on the horizon. Northern part of North Dakota, northern Minnesota, the upper peninsula of Michigan, beginning to see the northern lights now, but only now at KP4. At KP5, it's now sort of red alert stage. Things are looking up, and now further south, places further south in the US, but still the northern tier states are now seeing aurora, but still, nevertheless, maybe just a glow along the horizon with maybe some structure and form, maybe some motion, maybe just a glow. KP6, that's when people are starting to get really excited, because now places much further south, South Dakota, southern Minnesota, southern Wisconsin, are beginning to see the aurora. But once again, perhaps just a glow along the horizon at that point, which is neat, which is nice, and which you live in a location that doesn't see aurora at all, that's something. But to see even that, you have to get those kind of KP levels and be in that kind of region of the US to really stand a chance. The Pacific Northwest over to the west in Washington, even though the latitude is about the same as, say, northern Minnesota, the geomagnetic latitude is not the same. It's not as high. And so there's not a good chance of seeing the aurora even from Washington State or whatever. It has to be pretty high KP, as you see here, KP6, for them to see it as well. Now, to see the aurora overhead, that's the exciting view. That's where it starts to get really exciting and jaw-dropping and wonderful. Here it is at KP1, where northern Manitoba, like Churchill, is seeing aurora all over the whole sky at KP1. So kind of almost all the time, there's some sort of level. It may not be bright, it may not be colorful at KP1, but nevertheless, you're seeing pretty extensive aurora. KP2, it's further south. KP3, central Manitoba, northern Alberta, seeing it overhead at this point. KP4, Saskatoon and Edmonton are seeing aurora overhead. KP5, Regina, Winnipeg, and Calgary are seeing aurora overhead. We're getting really excited now. And at KP6, now overhead is visible from just that northern bit of the US, upper peninsula of Michigan, northern Minnesota, northern North Dakota at KP6. Takes something that high to see the aurora covering a large part of the sky. But that's a memorable night. But look where you have to be to see that. It takes KP 7, 8, or 9 to get the aurora far enough south that you're going to see it from, even then, still the northern part of the US. And so waiting for the aurora to come to you, you have to be pretty patient. It might be once a decade, perhaps, when it gets up that high and it's clear and where you are to see the aurora. You kind of have to, like an eclipse of the sun, you have to kind of plan to go to the aurora, not wait for it to come to you. It isn't just the KP value, however, that's important. We can get nights or predictions where the KP is going to be really high and may come quite high, but we see nothing. It just fizzles. There's been numerous reports like that. In fact, whenever there's a news report out saying, fabulous aurora this weekend, we almost kind of say, nah, that's jinxed it. It's not going to happen. Because this BZ, or in Canada here, we say BZ index, is also important. That's the direction of the sun's magnetic field, or the interplanetary magnetic field coming from the sun. That has to be south. The Earth's magnetic field is pointed north. They attract, opposites attract, and there's a better connection between the sun's magnetic field and the Earth's magnetic field. And so the stuff gets into the Earth's magnetic field better and is more likely to trigger a good display. So the BZ has to be south and as much south as possible. It's measured in nanoteslas. And here on this particular graph here, when I shot it, it was only minus 0.43 south, so not very much far south. But this particular graph shows you what's coming, because we have satellites to give us information. It says that in 45 minutes, it's going to be -5 south. And so, just wait a while, it's going to pick up, and it can happen. The aurora can suddenly brighten and pick up, and you get a substorm surge, and you do get a good display. But sometimes things just never go south. In this case, going south is a good thing. And so we need that BZ to be as far south as possible to get a good display. Now, the Earth is this dipole magnet, and it's like a big magnet in the side of it with inside of it, and with the magnetic field lines stretching out, like we see in this sort of put the iron filings on a piece of paper sort of experiment. And it's centered on the north geomagnetic pole, north and south geomagnetic poles, not the geographic poles, the blue line here, but the purple line, the geomagnetic poles. And those magnetic field lines arc out and then around to the other side of the world. And the particles causing the aurora, the electrons mostly, coming in, follow those field lines. They want to get to that core, that magnet at the center of the Earth, but they can't get there, of course. They get intercepted by the Earth's atmosphere in these two ovals. There's a northern and there's a southern auroral oval. There are Aurora Australis, the southern lights, but that oval in the south is primarily over ocean, a very cloudy ocean. It's not, the Aurora Australis is not seen very often, and it's just not over land. Tasmania and the South Island of New Zealand has a good chance of seeing northern lights from time to time, but even then the KP has to get up fairly high, 4 or 5 or so, to get it far enough north for them to see the Aurora Australis. It's in the north here where we're so fortunate we have so many land masses and accessible locations underneath the oval in the north to see the Aurora Borealis. Now, it can come to you to the south. For example, when I lived in Wisconsin in the early 90s, when I was working for Astronomy magazine, it was at a very high peak of solar activity. 91 was a great year. This was looking up over the whole sky, turning red from southern Wisconsin. It must have been KP 7 or 8 at least this night, perhaps. So it can happen, but it's almost maybe once a decade. It was a good year because April, another great red display. The whole sky turns red, as it often does when it's a very active display. To move that far south or even farther south, you got very energetic electrons coming in. They're lighting up the upper atmosphere with this red color, which takes a lot of energy to do. So those lower latitude auroras are often deep red and cover the whole sky. And so that alone is an amazing sight, but quite rare. Those shots were on film, and those were taken at the big solar maximum in early 90s. There was a fairly high solar maximum 10 or 11 years later, early 2000s, and we're into the start of cycle 25 now. We'll talk about that in a moment. This is a shot from home in Alberta at that solar maximum of the early 2000s. Once again, when we had several all sky, jaw-dropping displays over the whole sky in the early 2000s. And if you remember seeing northern lights as a child or whatever, or many years ago, it may have been one of these displays in the early 90s or early 2000s when it moved far enough south to be visible from the northern half of the United States, but fairly rare, almost once a decade. Now here, a few years later, in fact, past the last solar maximum in 2017, another all-sky display, now with digital cameras, so immediately the picture quality is improved, from southern Alberta from home here. And it is an all-sky display like this that is really what you want to see. Seeing the aurora low in the horizon is kind of neat, but that's kind of like a partial solar eclipse. You want to see a total eclipse? The difference is night and day. Well, an aurora overhead and dancing around in this coronal outburst is kind of what you want to see. And for that, you almost have to go to the auroral oval, go north, Norway, locations like that. Sweden and Finland as well cater to aurora tourists. Yellowknife, a favorite spot of mine to go in Canada's Northwest Territories, easy for me to get to. It's just about a 2-3 hour flight from Calgary, flights from Edmonton and Vancouver as well, to get to Yellowknife, fairly major city in Canada's Northwest Territories. Looking up, seeing the aurora dancing all over the sky. And to give you an idea of what it looks like, here's a real-time movie of the aurora from Yellowknife. Wow. This is not time-lapse. This is not sped up. This is actual real-time movie. Cameras can do this now, showing you the motion, the dancing, the rippling, once it gets really active. And the colors, you do see those colors, the green, talk about that in a moment, and the pink fringes along the bottom as well, which show up, and just these fine scale rippling as the aurora dances along the curtains. And you just imagine that over the whole sky. This was a modest display. It's just astonishing. It's hard to believe the sky is capable of doing this. So that is a real-time movie. I'll talk about photography towards the end, but this is a still shot from a time lapse I took in Churchill. So now imagine the whole sky lit up like this and just dancing like I just showed you, and with the green curtains and the pink, incredible pink purple fringes along the bottom, which easily show up to the naked eye. When the aurora gets that active, these colors get bright enough that there's no problem. You see those colors, and it's just draw drop. You just lie back and just gaze up in wonder and amazement that it's capable of doing that. Now, one of the misconceptions I wanted to dispel is that you hear news reports now and then in your news feeds. The aurora is moving away. See it now before it disappears. It's moving north. The magnetic pole is moving north. It's taking the aurora with it. It's moving away from North America. Now, don't worry about that. The north magnetic pole that our compass points to is moving away, as the chart on the left here shows. It is moving away from us. It's heading very rapidly north. That's not where the aurora is centered. The aurora particles are wanting to get to the north geomagnetic pole, which is different from the Earth's magnetic pole. The geomagnetic pole is the center, the focus of the auroral oval, and it hasn't moved much in decades, and it isn't moving much. It's in the Canadian high Arctic islands, sort of due north of Manitoba in longitude. And so, for example, the Churchill Northern Studies Center, where we go, is built on the site of the old Churchill rocket range, built in the 57 for the International Geophysical Year and operated for several decades till it was shut down in the 80s to launch rockets into the northern lights, into the auroras, right underneath the aurora. It still is. The aurora hasn't moved. The rocket range is shut down, but the aurora is still there. There's a very active rocket range in Poker Flats, Alaska, that is one of the main centers of sending rockets up and studying the aurora in situ, as it were, in Alaska. But this rocket range is shut down, and kind of a good thing, because we wouldn't be there as tourists if they were still firing rockets from there. So don't worry about having to suddenly rush up there to see the northern lights before they disappear. They're not going anywhere. We are still well placed on the North American side of the world to see the northern lights at a relatively low latitude. Churchill's 58 degrees north, the Yellowknife 62, Alaska 64, 65. Now, however, that is far enough north that you don't want to go in midsummer. So it's important to know when to go as well to see the northern lights. Now, from further south here where I live, southern Alberta and the southern part of Western Canada, we can see the northern lights year round. This was a fabulous display right on summer solstice night a few years ago in June 2015. All over the sky, the warnings were out, expect something good tonight, and it turned out to be good, KP6 or whatever it was. The sky is not dark for us, it's still rather bright with twilight, but it's dark enough that we can see aurora year round here from this latitude of 49, 52 degrees north, something like that. But from further north, it's not going to get dark enough to see the northern lights in summer. This was a fabulous night a year ago in July 2020, when many of us were out. It was such a clear week that week. We had the comet and we had the northern lights, and Steve appeared as well. We'll talk about that. And there were noctilucent clouds. It was a night we still talk about. That there was so much going on. It was fabulous. So we can get northern lights here year round, but it still takes a fairly active KP level, 3 or 4 or 5, to see them in midsummer. If you want to go up to the auroral oval, to the aurora tourist destinations, you don't want to go in midsummer. They're far enough north that it's not going to get dark in midsummer. If you want to see the midnight sun, great, go above the Arctic Circle, but you won't see the aurora. Churchill, Manitoba, kind of the most southerly aurora tourist destination because it's due south of the geomagnetic pole. 58 degrees north, so it's not in the Arctic officially, it's still in the province of Manitoba, 58 degrees north, late August to late April. In between that, spring to late summer, it's not dark enough. Midwinter is the prime time where we take tourists there to the Northern Studies Center. ChurchillScience.ca, I put in a plug for them. It's a great spot to go. Polar bear tourism in October and November, but Aurora tourism in February and March is the second most popular tourist season now, or was. We hope it will be again starting next year. But we go there in midwinter because that's when it's coldest. Yeah, and it's cold. It could be minus 30 Celsius, and whatever that is in Fahrenheit, it's darn cold. But when the aurora gets going, you don't worry about it. You don't are concerned about how cold it is. It's so amazing. That's when the skies are clearest. So that's another myth that somehow you've got to go to the Arctic climates in the middle of winter when it's cold because that's when the aurora appears. No, the aurora is there all year long, but from further north, it's not going to be visible in summer when it's warmest, but fall and spring can be fine, depending how far north you are. The aurora has nothing to do with how cold or hot or what it is, the weather down here on Earth. They can appear at any time. The aurora is there all year long. So it doesn't appear only when it's cold. It's when it's cold, it's when it's often clearest at the northern locations in midwinter. The nights are longest as well, and that's when the peak aurora tourism months typically are, because that's when the skies are clearest. So that's in February and March is when we take tourists up to Churchill, to the study center there, because out of decades, only a couple of groups have ever been completely clouded out in the typical 5-night program. So the aurora has nothing to do with the weather here down on Earth. That's kind of another misconception. Oh, it has to be cold to see the aurora, or it's too cold for the aurora to appear, other kinds of tales. That's not true. It's occurring hundreds of kilometers up, way above the stratosphere even. In Yellowknife, 62 degrees north, their aurora season is a little shorter because than Churchill, because they're further north, September to March or so. This was a view in September a couple of years ago, looking south of the aurora all over the whole sky, looking south towards downtown Yellowknife from a spot called Pilot's Monument in Old Town Yellowknife. What a fabulous night that was all over the sky. I love to go to Yellowknife in September, early September, because A, it isn't really cold yet. The lakes have not frozen, and it's a nice window of opportunity between the end of August when it's starting to get dark enough to see the northern lights and before things freeze up and it starts to cloud up. As the lakes begin to freeze, and it's on the shore of a very big lake, it starts to get cloudier and cloudier, and by late September, it's cloudy a lot. But early September, the first 2 weeks are ideal, and I've been up there a couple of times, and it's fabulous. You get the reflections over the lakes. This is Prelude Lake. It's a wonderful spot to go up to Yellowknife. I hope to get there next month. We'll see how the travel restrictions open up. Norway being farther north, on that part of the world, you've got to go quite far north, above the Arctic Circle, to get into the auroral oval zone, because remember that magnetic pole is tipped over, that oval is tipped over towards our side of the world. So in Norway and Scandinavia, you've got to go way above the Arctic Circle, Tromsø, places like that in Norway, 69 degrees north. And we were on the ship, so we actually traveled north up the coast above the Arctic Circle, right up to 70 degrees north, and then back again. So their season is October to early March or so. Take the trip in June, you'll see wonderful views of the midnight sun, but it won't ever get dark. Well, to talk about what causes the aurora, you might think, oh, I know, stuff comes from the sun and enters the magnetic field and triggers the aurora. Well, not quite. You know, it's caused by sunspots, is the arm waving. No, it's not necessarily caused by sunspots. The sunspots are a visible manifestation that get counted very rigorously. And this plots the number of sunspots from those high peaks in the early 1990s, early 2000s, the last peak, 2013 or so, much lower. And we're on the upswing of cycle 25 now, where sunspots appear with greater frequency and number. How high the next peak is going to get is open to debate. Some say it's going to be quite low, like this chart depicts. Others say it's going to be quite high again. And so it all depends on the models people are using for what's going on inside the interior of the sun. And it's opening up that sun and revealing this dynamo that's inside the sun, as we can kind of do now with instrumentation, to figure out what's going on inside with some degree of accuracy. The sun is this big sphere of plasma, of course. It's rotating at different rates. The equator rotates faster than the poles. The interior rotates at different rates. So all those magnetic field lines generating by all this moving plasma gets twisted up over the years, and they break out onto the surface as these magnetic storms, sunspots, and flares, and increase in number. And then the magnetic field lines kind of relax and reset themselves, and we get back to a quieter solar minimum time, which we're just exiting now, and the sunspots are increasing in number. But exactly what's going on in the sun is open to various models, and we'll see what the next solar maximum brings us. So it is solar sunspots, or in a way, which are an indicator of solar activity, but they don't cause the aurora themselves. It's activity flares associated with sunspot regions. So when there's a great big sunspot appears, there's a greater chance for something active happening on the sun, like a flare. This one of these big explosions, M-class, or the biggest X-class flares that blow off a stream of particles, in fact, blow off part of the sun's atmosphere and send stuff our way, perhaps, if we're fortunate or unfortunate, depending on your point of view, is when we're going to get something really bright happening for northern lights. And the warnings go out, because we have satellites now observing these coronal mass ejections, where a big flare blows off part of the sun's atmosphere, and we get this bubble, this burst of material coming at us, perhaps, or to the side, it misses us, or away from us in the other direction. There's one there. And so these CMAs are something that we're watching for all the time, to see if something's coming our way that might cause the northern lights. But even when we don't have a lot of activity like that, for example, at solar minimum, we can get these coronal holes coming around once every time the sun rotates. And these are windows out of which solar wind can blow more strongly. And just those coronal holes can increase the activity of aurora and give us some great display. So we don't necessarily need really bright active explosions on the sun. There's always solar wind blowing from the sun all the time, but occasionally there's these bright bursts and bubbles that are detected by the satellites, and sometimes they kind of miss us and blow off to one side and really doesn't produce anything, but occasionally, like right there, we get hit with one, and that's when things really start to heat up and when we might get a great display. As that stuff crosses the interplanetary space from the sun to the Earth, it plows into the Earth's magnetic field. These are like deflector shields around us, protects us from the full onslaught. The solar wind compresses the magnetic field on the sunward side, but also compresses the field lines in the tail, in the night side of the Earth, squeezes those magnetic field lines together to produce what's called a magnetic reconnection events. And so it's those kinds of snapping together the field lines that produces a rain of particles down onto the night side of the Earth. The particles that cause the aurora come from the tail, the magnetic tail of the Earth. They don't come directly from the sun. And they come about and rain down on us with enough energy to produce aurora as a result of events like this, where the magnetic field lines snap together, compressed by the pressure of the solar wind flowing past it. It imparts energy to the particles that are already in the atmosphere. And it's these kind of magnetic reconnection events that are fairly important to get a really bright display of aurora, or an outburst, a solar substorm, as we call them. That's the idealized view, but this is more of reality from actual data. It's a very messy magnetic tail, like blowing in like a windsock in the wind as the solar wind flows past us here from left to right, stretching out the tail and squeezing those magnetic tail lines together many times through a night. And we can get outbursts of aurora throughout the night as we get these reconnection events. And as the speed and density of the solar wind changes, it imparts even more energy to the particles that are in the magnetic tail. And the process of forming an aurora is kind of analogous to for those that remember them, cathode ray tubes, CRTs. We used to sit in front of them at our computers or watching television. YouTube is called YouTube because television used to be picture tubes, right? Cathode ray tubes, where you have a source, a hot source that's lit up and produces electrons. Magnets accelerate those electrons and modulate them, paint them across a screen to produce a picture. A phosphorescent screen in the case of a television or an oscilloscope, but in this case, it's our atmosphere. So that's kind of the analogy to what's happening, but the source of that, the cathode, as it were, that produces that rain of electrons is here in the tail of the Earth. The aurora particles come from kind of this location in the tail, a few Earth radii down the tail. And so the aurora is often most active at midnight, solar midnight, because that's when we're looking right down the tail at these particles coming at us. So often from a aurora location like Churchill and Yellowknife or whatever, the aurora is best around midnight. Not always, but typically. The particles that cause the aurora don't come directly from the sun. In fact, many of them don't come from the sun at all. The particles that come direct from the sun can only get to the Earth's atmosphere through those two regions on the day side of the Earth called the polar cusps. And particles from the sun can get into and flow along the field lines at those two regions, the polar cusps, and create auroras by day on the day side of the Earth. You say, oh, how do I see auroras in the daytime? You go up to a place like Svalbard, 80 degrees north, and in December and January, it doesn't get light. The sun never rises. It's perpetual twilight or night all day long. And so you can see weak daytime auroras, but they're always very weak because even during a major substorm from the sun, the particles coming direct from the sun do not have enough energy to really produce a bright aurora like we want to see at night. The nighttime auroras are caused by particles coming from that region, that source region in the tail, and that region, those particles have to be energized, imparted a lot of energy to by the flowing solar wind. And the electrons and protons as well, but mostly electrons that produce the nighttime auroras don't necessarily come from the sun. Some of them have come from the moon. Some of them have come from the Earth. They're in the magnetic tail already, and they get more energized by the intense flow of solar wind past them, imparts energy and creates these magnetic reconnection events. So the aurora outbursts are caused by the flow of the solar wind interacting with and adding energy to the particles that are already in our magnetic tail. The solar wind particles themselves don't have enough energy to produce bright aurora. It takes these aurora particles, which have come from the sun, the moon, the Earth, that have more energy, and they've imparted that extra energy through that interaction in the magnetic tail of the Earth. So to say that, oh, there's particles coming from the sun, they're going to enter the Earth's magnetic field and then rain down on us and produce the aurora, that's not necessarily what happens. It's not that simple by any means. So as I say, when you see aurora, some of the particles that made them may have actually come from the moon, for heaven's sakes. Well, how to know when to look for the aurora, even where you are at home, or if you're on a trip to see the Northern Lights, you still want to monitor the status to see when there could be an outburst, when there could be a brighter display. This is a shot from Yellowknife from right downtown, Samba Cay Park, overlooking Frame Lake and the Prince of Wales Museum, right downtown. You can get views of the aurora. Now, this is the kind of view you will see at a site like spaceweather.com that I'm sure many of us use, and it's called the Ovation Oval. It's from NOAA. It depicts the current activity level of the aurora. It's not a picture from space, but it's a picture from data that shows us the current activity level, and that's kind of standard. That's sort of the run-of-the-mill, always there kind of aurora. So say from Churchill and Yellowknife, they're seeing aurora overhead, perhaps even that night, but we're not seeing anything from further south. when it goes like that, and you got this literally red alerts going out, and the elevation oval is turning red, and it's moving south. That auroral oval is widening and moving south, and the red line there is the view line. That's where you have to be, at least as far north as that, to see the aurora on the horizon. And so it's now appearing overhead from more southerly locations. But even so, on the horizon, maybe only just from the tippy top, more northerly states of the United States. Alaska, no problem, however, of course. And so that's what we look for. And apps that we have on our mobile devices, Aurora Forecast is a favorite of mine. It shows you that elevation oval and then shows you at 3-hour intervals what the KP is predicted to be. It may or may not turn out to be true, but all these apps use the same data from NOAA's Space Weather Prediction Center. So it's not like one app is more accurate than another. They all draw upon the same data. It's just a matter of how they depict it. This one is kind of easier to interpret. This one is quite popular, Space Weather Live, more technical. It's got more numbers and data associated, but there's the numbers. KP, we're talking about the BZ index, the direction of the magnetic field, here showing you at minus 1.4 south on this particular night, and all kinds of other numbers for solar wind speed and density as well. So it's a more technical app, Space Weather Live. It's also a website as well. So we look at those to see if there's something coming. But again, there's never any guarantees there's going to be a great display. That BZ can go north and south very quickly. Now, when there is a great display, what can you see in terms of the colors? That's what people want to see. It's not just the changing forms, but the colors that show up so vividly on the cameras. This is a view looking straight up at this coronal outburst, as we call it, where all the rays are converging together at the zenith. Fabulous. It's, I rate it right up there with the total solar eclipse in terms of, wondrous value. It's wonderful. Something you must see. Now, the colors typically of aurora are green and red, and that's from oxygen. Atomic oxygen glowing, and the camera picks up those colors very, very easily here. Your eye, however, on a typical display, lower level display, weak to average, is going to see something like that. More monochrome, just subtle color. The greens show up most easily. Your eye is most sensitive to green, less sensitive to red. And it varies in terms of where your sensitivity of your eye kicks in terms of being able to see colors. I've been standing with a group of people, and the colors to me and to many people are obvious. Other people are saying, I don't see colors. Where are the colors? It just looks gray. So it depends on physiology and also psychology. It's expectations, what you expect it to look like. But the cameras pick up the colors very, very easily. Even on a faint display, your eye can see it when the display gets quite bright. And as oxygen produces the green color at a lower level, and oxygen produces the red at a higher level in the atmosphere. It's a more rare transition, takes more energy, and it doesn't last very long, so it takes almost a perfect vacuum for it to happen at all. And so the red is the upper level red that the cameras pick up, but it's tougher for your eye to see that. When the aurora gets very active at KP 8 or 9 and moves way south, that's the red you're seeing covering the whole sky. But it takes a very energetic display to see it. And this particular night, there is also another faint red arc above it. It was actually more south of the main oval. It's called a SAR arc, stable auroral red arc, which is something that your eye does not see. It certainly wasn't visible to the eye this night. I was taking pictures of the Milky Way, and the camera's picking up this faint red arc. It's another strange and somewhat mysterious form of aurora, the stable auroral red arc, which is always more south of the main auroral oval in the northern hemisphere. Now, the greens are the brightest, most prominent colors. They're what show up easily at first when the aurora brightens, but you get these pinks as well, along the bottom of the curtains, as I showed in the movie earlier on. That's from molecular nitrogen, which is lower in the atmosphere where it's denser, but it takes a fairly energetic aurora for the electrons to get down that far and start to excite the nitrogen molecules, and they glow in this mixture of blue and red light to form quite vivid pink. And your eye does see that pink quite nicely as well. This was a bright display from Churchill where it, just for a few minutes, exploded over the whole sky. And your eye was certainly seeing those pinks and the greens as well. But the colors, because in cameras, of course, show up more easily because they can do longer exposures than your eye can. Well, how to capture the aurora, because everybody wants to get a picture of the aurora because the cameras do often show you more than what your eye can see and picks up the colors more easily as well. And these days, most people, aurora tourists in particular, have a camera in their pocket capable of doing the job. Your phone camera can do an amazing job these days if it's a fairly recent model camera. There are specialized apps that I've noted here: Northern Lights Photo Taker, Northern Lights Photo Capture, Nightcap as well, which take maybe longer exposures than what your camera can do natively, or they take many exposures and they stack them together internally in the camera. Quite amazing. Something we astrophotographers have to use with, use our computers for our deep sky pictures. So there are these extra apps you can get, but these days, even the native camera app in most phones, most recent phones made in the last couple of years, can do a pretty credible job. The key thing is to hold the camera very, very steady, because the exposures might be several seconds long or several seconds worth of exposures. And if you blur it around, move the camera around, it's going to be blurred. So they can do quite an amazing job, enough for your typical aurora tourist to be satisfied they've got their picture of the northern lights. But most people are going to want something, amateur astronomers dedicated to the task who've gone north and made the effort, going to want to get some better quality, publication quality pictures. For that, you need a DSLR or one of the new generation of DSLMs, mirrorless cameras, and a wide-angle lens, as wide as you can get and as fast as you can get them. An 8mm fisheye takes in the whole sky, so there's no question about where do I aim the camera. It just takes in everything. Full frame fisheye lenses, 11 to 15mm, are great as well. But even then, the aurora can move around enough. You got to move the camera around during the display. 14 to 20mm fast wide angles, f1.4 to f2.8, keeps the shutter speed as quick as possible. Those are the kind of lenses you need for an aurora trip to make it really worthwhile if you want to get some great pictures. When the aurora is faint, as it often is, even during a good display, at the start of a display, it starts faint, or as it might be during a typical KP3 or 4 display, just a faint arc as it is to the north here, but there's a Steve arc appearing as well here. It might be 10 to 30 seconds, still fairly fast, f2 to f2.8, and a high ISO 1600 to 3200 for a picture of a fainter display. That the fainter displays often are moving slowly if they're moving at all, and so the longer exposure isn't too detrimental. That's what you need to pick it up. And if you take a time lapse, you take dozens or hundreds of such pictures and string them together, and there's Steve appearing in a time lapse. There he is, and there he goes. He's only there for a few minutes. You can get a time-lapse movie showing the motion, the developments of the aurora, and just take pictures like at 1 second intervals between shots. Bang, 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 just as quickly as you can from exposure to exposure to exposure. You can tape time-lapse movies. When the aurora gets quite bright, especially if the moon should be up like it was on this particular night from Churchill, when it gets very bright, you can use shorter shutter speeds, 1 to 4 seconds. That freezes the motion of the aurora a little bit better because when it is bright, it's moving more quickly. But that still means a fairly fast lens. f1.4 to f2.8, maybe a lower ISO, so there's less noise, electronic noise in the picture as well. And it varies. It's going to vary minute by minute even during a display. But you can see on the back of the camera what you're getting and see if you're under or overexposing. This particular picture was kind of a favorite of mine because it ended up on the stamp issued by Canada Post a couple of years ago. So that was kind of an honor and treat. to get one of the Aurora pictures on a stamp taken from Churchill. And it was one frame out of a couple thousand, I think, I took of a rapid fire time lapse. So now I'm using very short shutter speeds and taking lots and lots of pictures, 1 second interval. So a couple of second exposure, bam, the shutter closes, it opens again, and just taking rapid fire time lapses it's sped up. It is a time lapse that's sped up, but it really better captures what you were seeing and the motion of the curtains and the aurora and this kind of rapid cadence time lapse. But today's cameras are so good, they can take movies, actual real-time movies. I showed one earlier on. This is one from earlier this year from home, which is the aurora to the north, April 16th, showing you the real motion. It's not sped up. So this is a movie taken with a Sony a7 III camera. It takes the new generation of mirrorless cameras to do this. Old DSLRs really can't do this very well. The new generation of mirrorless cameras have more sensitive and more video-centric circuitry. They can go up to 12,000, 50,000 and still produce a pretty clean movie image. Takes a fast lens. The key is a fast lens, f1.4 to f2, to capture real-time movies of the aurora. But it is possible now with today's generation of cameras. If you're shooting still pictures and time lapses was made up of hundreds of still pictures, shoot RAW. Don't shoot JPEGs. You're throwing away half your data with JPEGs. Shoot RAW. When the aurora gets really bright, like it was here, it's now way overexposed. I just didn't catch the camera and reset the settings in time, and so it's way overexposed. But in RAW, you've got so much dynamic range to play with. I could recover, not all of it, but a fair amount of the detail to make a decent picture out of it. So shoot RAW, because that aurora is a challenging subject when it gets bright. It's such a dynamic range of bright to faint that you need to shoot RAW files and learn to process them. Keeping your camera warm if you're going up to the Arctic territories and Arctic latitudes in midwinter when it is clearest, but it's coldest, is a challenge. I use these little quilted parkas to help keep camera warm, some heater packs inside them, maybe heater coils on the lens. If you're just shooting a few still pictures, it's not an issue so much, but if you're shooting time lapses out there for an hour, 2 hours, your camera battery is going to die in the cold, typically after an hour and a half, maybe, but they last surprisingly well, even at cold temperatures, but eventually they're going to die. So cold temperatures is a challenge for the northern lights, there's no question. Well, to finish off, let me talk about Steve. You may have heard about Steve, the mysterious aurora named Steve. Here he is over my house a few months ago, in fact, kind of a purple mauve arc across the sky, and very unusual. It's been sighted for years, decades, centuries. He's not new. He's just new in the sense that it's only in the last 5 years that it's been identified as a unique phenomena, something worthy of study. It's called Steve. It's now named for the acronym Strong Thermal Emission Velocity Enhancement. It's a back acronym. I'll tell you about where Steve came from in just a moment. But this is what he looks like. And this is where he appears. It's an arc across the sky, well south in the northern hemisphere here, well south of the main aurora. The main aurora is off to the north, off to the right here. Again, this is from where I live. And it was fairly active earlier on this night, still reasonably active, but it has died down. That's when Steve appears. When the substorm kind of dies down, and then we start to see this, to the eye, maybe featureless gray arc starting to appear going across the sky. And the camera picks up this pink or mauve color, sometimes white bands as well. And it appears always south of the main auroral oval. And so we're well positioned here in Western Canada to see it. It appears right on top of us. And it was kind of where it was discovered, as it were, in terms of identified. It's not an aurora per se. It associates with an aurora, it appears with an aurora, but it's not caused by electrons raining down from space along the magnetic field lines, but it's caused by hot gas moving from east to west. always east to west, across the sky in this tube or curtain across the sky, across the continent. And so it can span the continent. And up very high, higher than the green part of the aurora over there, 250 to 300 kilometers altitude. And those height values have come to a large extent from amateur pictures like this, taken at different locations at the same time, and then scientists use them to create a parallax measurement to figure out where Steve appeared. Here's the same night, same pictures, just stitched together to a fisheye view to show the relationship of Steve to the main aurora. It's appearing overhead for us, but the aurora off to the north. And he can change form and appear in different forms. This is a bit of an emaciated Steve, as a thin, very thin line across the sky, with a bit of a purple color as well still. And so he can take different forms, and he can have these. He can have fingers. These green picket fence fingers, we call them, can hang down from a Steve band and slowly ripple as well from east to west. This was actually, again, a few months ago, I think. This was a classic Steve a couple of years ago, where we see that purple arc, a white band as well, and then the green fingers coming down. And they do appear to be more like a normal aurora, and that they're caused by electrons raining down, but electrons generated by this hot thermal flow of gas from above. So it's an unusual phenomena. Scientists are studying it. Scientists like Elizabeth McDonald on the right there from the Goddard Space Flight Center, helped by citizen scientists like myself, Chris Ratzlaff, circled on the left here. And this is kind of where Steve was kind of first identified, or at least scientists first picked up their ears and say, hey, this is something unusual. It was at the Kilkenny pub, a watering hole near the University of Calgary a few years ago. Elizabeth McDonald from the Goddard Space Flight Center was in town attending, working with the research scientists at the University of Calgary. The call came out from Chris Ratzlaff, who was the administrator for the Alberta Aurora Chasers Facebook group. Say, hey, come on, we're having some beers at the Kilkenny after the symposium. Join us. I didn't that night. This was a couple of years later when we had another reunion meeting at Kilkenny pub. But that night, one of the other local photographers, Neil Zeller, takes out his iPhone and says to Elizabeth and Eric Donovan, who I'll show you in a moment, says, I took a picture of a proton arc. And Eric says, no, you didn't. Yes, I did. Here it is. He says, no, that's not a proton arc. Proton arcs are different phenomena. They're not visual. They're subvisual. That's not a proton arc. But what is it? And he said, this is something we haven't really seen before, paid any attention to before. What is it? And then Chris says, well, what do we call it? Because we are photographing it. We're photographing it all the time. What is it? And he suggested a name, Steve, from the movie Over the Hedge, where the cartoon characters, animated characters, are afraid of something that's on the other side of the hedge. And what do they call it to make it less intimidating? Well, let's call it Steve. And so it's kind of non-committal in the sense it doesn't say what it is. And so the name stuck. And Eric Donovan, who tells a story of how he met Steve in a TEDx talk here, you can look that up at the TEDx Calgary site, tells you how he took that initial pictures and said, hey, there's something of interest here to study. And it's being studied now by scientists around the world. What is this phenomena? And yet it was sparked by photographs, and still to this day, it is photos taken by citizen scientists, by folks in the Facebook Alberta Aurora Chasers group and others around the world who have contributed some of the data. It's an amazing story of citizen science working with top-level scientists and working with satellite data, but also working with our pictures. And our pictures have appeared in scientific papers, and our names have appeared on the masthead of scientific journals in papers as co-authors to papers about Steve. And so it's a fascinating story that shows you with something that has been cited for thousands of years, we still don't understand. We still don't understand what's going on up there just 100 to 300 kilometers above our heads. It's the source of so much magic and mystery and folklore, and now science, and still cutting edge science, but it still produces this magic feeling of wonderment when you can see the Northern Lights for yourself. And I hope you will take the time to do that and chase the Northern Lights as these folks were doing here a couple of years ago, and just take it in. It is a sight to behold, and I hope you'll enjoy it. And I hope you've enjoyed my little tour of chasing the Northern Lights. My name's Alan Dyer. It's been my pleasure to give you this presentation. That's my website, amazingsky.com, and I'm the co-author with Terence Dickinson of the Backyard Astronomer's Guide, which has been out for 30 years now in various editions. People have been asking us, when's the new edition coming out? Well, this fall. This autumn, the new 4th edition will come out, totally revised, revamped, all new pictures as well, including pictures of Steve in the new edition. So we hope you'll enjoy that when it comes out later this year as well. Thank you very much for watching this evening, and do enjoy your chase of the Northern Lights.
Thank you, Alan. That was amazing.
Thank you, Terry. I'm glad that went very well. And thank you, Scott, for hosting that and feeding that into the system. Yeah, it is a wonderful, wonderful story, the Northern Lights. You know, it's something that it's got so much rich lore, folklore, and magic and mystery. And I didn't even get into that at all. You know, how the peoples across the northern part of the world interpreted what they were seeing. And now it's still this magic of the wonder of seeing it for yourself, but also we still don't understand what's going on up there. And we're still discovering brand new things, you know, even the last 2 years, new types of, and there's other types of aurora phenomena like dunes. I didn't even get into that, and new forms that we're just discovering. And the digital cameras kind of help make that possible, and the satellite data that we have as well. So it's a rich, rich story, the Northern Lights, and the Southern Lights as well, but it's the Northern Lights that we see more often.
Yeah, it's amazing to me because if you see it once, it doesn't matter. It changes everything about it, the structure, the movement, everything changes every time you see it. It's still the same basic science, but what you see every time you look, the shapes that sometimes when you're taking a long exposure, how many times have you seen a shape in the aurora, you know, by the time that single exposure was done? It is amazing to me what you get out of this. It just makes you want to keep seeing it.
Very much so. It's like anything else in astronomy. You know, you can go to see a total eclipse and you think, well, I've seen it. That's it. No, come on. The first thing you want to, after you see one, is when's the next one, right?
Yeah, exactly. That's the first
or even just a starry night sky, right? Okay, you've seen it. Of course you want to see it again. And as you say, every display is a little different. And people locally here in the Alberta Aurora Chasers group, I mean, gosh, they're getting excited if it's KP3 or 4 and there's a little bit of an arc in the north and the like, especially nowadays with so many people living in cities and stuff, you have to make an effort just to get out of the city to see the Northern Lights. I'm fortunate, and as I said at the beginning, to live in the country where I can just literally out my kitchen window and see it and appreciate.
That is amazing.
There's a few questions.
Yes, go right ahead.
Let's see, comments too. And people said, wow, fantastic talk, fantastic presentation, really enjoyed that. Laura Landon from who's on YouTube says, thanks for the great talk. How did you make the photo of Steve on the left and Aurora on the right?
Well, those two pictures of Steve showing the full arc and then the Aurora on the right, they were a panorama where I had the camera, gosh, I think it was like a ultra wide angle lens aimed vertically, 14 millimeter, and then 1, 2, 3, 4, 5, 6 pictures, then stitched them together. And Photoshop can do that. It's a little tough with that kind of panorama, all sky panorama. Use a program called PT GUI, which is specialized in panorama stitching. And then you can decide whether you want to put it in a rectangular format or a circular format. So those are two pictures of the same pictures, source pictures, just reprojected differently as a panorama. So that's what that was. But though that, in fact, that picture was just appeared recently in a Geophysical Research Letters paper about the SAR arc and trying to tie the SAR arc into Steve and trying to relate those two phenomena. And so that picture was science data for some researchers, including from Goddard and from Haystack Observatory. And so, and I just bought a new fisheye lens, almost for Steve, just because when he appears, you want to get the whole thing because you're taking data. This could be useful information, and it's hard to know where to point. So use a fisheye lens and get the whole thing all at once.
Mike Overacker watching on YouTube. Is there any association between aurora and electromagnetic sprites from thunderstorms? I
don't think so. I'm certainly not an expert on the mesosphere and what goes on. I don't think so. In terms of one causing the other or one affecting the other, as far as I know. But that's another phenomenon in the upper atmosphere. It's only been kind of identified in the last couple of decades as the sprite phenomena, which comes from below, where the aurora is coming down from above. And I'm not even sure the difference in altitude. So no, I don't think so.
Okay. Maynard Pittendray. Oh, he's with us. He was talking about seeing aurora only once in his life and very briefly in Georgia, just north of Florida. I have a question. How often do you think that aurora can be seen from, latitudes down to the United States?
Well, the southern U.S., it is your once in a lifetime kind of occurrence, perhaps. Well, once every decade or 2 decades, around the peak of a solar activity every 10 or 11 years, or on the downside of the peak is often when the biggest storms are, oddly, 2 or 3 years after the peak. And you might get a KP 8 or 9. I mean, if you see something like that appearing on spaceweather.com, get out there because that's your chance. And from the southern U.S., you see reports and even pictures from places like Arizona and Utah, what they're seeing is a red glow in the northern horizon, perhaps, and that's something, but maybe not a lot of activity. But it can happen. Gosh, during these superstorms like the Carrington event in 1859 and other rare events, they can go right down into the Caribbean, for heaven's sakes, where they're seeing the northern lights in Mexico. I mean, that's extremely rare. And so the southern U.S. is going to be once a decade. And how active this next peak is, as I said in the talk, open to debate. Scientists are making different predictions. We'll see who's right, but it will take a quite high peak to get a chance of something like that being seen in the southern U.S. That's why I say it's like an eclipse. You got to go to it because otherwise, as Maynard was saying, it's once in a lifetime.
Yeah.
Remember seeing the northern lights, and the problem is, if you remember seeing the northern lights 20 years ago, 30 years ago, 40 years ago, as a child or a young astronomer, there were no artificial lights around at that time, not as much, and so you saw it from your backyard. You wouldn't now. Right? And Kelly Beatty's talking about that in a day or two. We all know that, and so that's why. You don't see the noise as much anymore. No, they're just happening just as much. You live in the big cities and it's just lit up and you're not seeing them at all.
Yeah. Let's take one more question if there is one, and we're probably
there's just a couple of comments. Julian Parks watching on Facebook says, "Thanks, Alan. These have been a great guide. The Backyard Astronomer's Guide," and she put a link down to Amazon where people can buy that. Other people too have chimed in because it's a great book. So.
Yeah, we did a lot of work putting in the new edition. Terry and I didn't want to tackle that new edition because the old one was 10 years before, and we thought, how much work is going to be. It's amazing how much has changed in that 10 years in the hobby. And Scott, about that with all the equipment and all that.
Oh yeah.
But even in the sky, what we know. And as Dave was just talking about, Dave Eicher was just talking about in terms of research and whatnot, how much has changed. But it's almost a total remake. Almost every picture changed except for a picture of Comet Hale Bopp or something for nostalgia purposes. Almost a totally new book, remake over for the 4th edition. Not out yet. I have a copy in the next room, but it won't be out for sale until later this autumn, depending on when the slow boat from China arrives with the cart.
They have been slow. So.
Yes, that.
I look forward to seeing that book. Thank you so much, Alan.
You're welcome.
Really appreciate the talk.
Thank you, Terry.
And I guess now we need to move on. So thanks again, Alan. And Carol, how about Carol Orge is the president of the Astronomical League. And I think he and Ron Kramer will be presenting the G.R. Wright Award. So Carol, if you're there, go ahead.
Terry, I'm ready to go eclipse Aurora chasing is what I want to do.
Oh, yeah.
The last one I saw was in Kansas City in 1991, and it wasn't anything to write home about, but so I'm overdue. So
yes, you are.
Curiosity, certainly. Well, one of the major neat things about being president of the Astronomical League is being able to recognize people who have given a ton of work to the organization, the adults. And this year I was faced with a dilemma. Who do I choose? And I was just coming up blank. It just wasn't clicking quite. And then I thought, wait a minute, there's a certain group of people in this organization who have really kept this organization afloat for the last year, communicating with our readership, our members, and that being the Reflector staff, the Reflector magazine staff. And I thought that's how we need to do it. For you people who are league members, you recognize this. This is a Reflector cover. This is M45, the June edition that was taken from Las Cruces, New Mexico. And so that's an idea, that's an example of the quality that our staff puts out 4 times a year. When we made the decision to go with this, I thought, well, we've got 7 members on the staff of the Reflector. However, 2 of those people have already received a G.R. Wright Award. So how are we going to get around this? So we came up with a special award, the same language, but a special award. So what I'm going to do at this point, well, before I do that though, here's the inscription that went out on all the plaques. As a member of the Reflector magazine staff, you have been an essential part of keeping high quality communication flowing to our membership despite the pandemic. And this is so appropriately awarded. Ron, do you have your plaque with you? I want to introduce you as manager.
Sure, why not? Yeah. I dug it out of the trash. I figured, I've got so many of these things.
Okay, that's the one that was sent to Ron with the same language, except his is called special because you can't win the Wright Award twice. He got it for another volunteer activity earlier.
Carol, you do realize this thing is out of date because it says 18,000 members.
Well, sometimes the lead time is a little much. Yeah, we have gone to 20,600 in the last month or so officially. So yeah, it's a little bit big. Okay, Ron, what I would like to do is go ahead and introduce the members of the staff who are here. I think we've got a couple that are not here. First of all, Chris Larson, who is the editor of the magazine. Why don't you say a few words, Ron? You hired most of the people on the staff, and they've done a superb job for many years.
Well, yeah, everybody I see here, I think I've hired. When I took over, I've been a league member since 2008, I think it was. And I think it was in 2009 or 2010, there was a little blurb in this magazine that I was getting called The Reflector, that they needed an assistant or an associate editor. And I had nothing else to do, so I said, yeah, why not? Never dreamed that 10 years later, I'd still be that deeply involved in the production of this magazine. When I took over as editor several years later, we were, I think, about 20 or 22 or 24 pages. Most of it, or a good part of it, was still black and white. And it needed some work. And throughout my career, I'm a retired physicist, but worked for a small company called Philips, you might have heard of. But during my career, I didn't believe in just maintaining anything. It was either grow it or get rid of it. And we didn't want to get rid of it, so we grew it. And I believe this issue coming up is 40 pages or 36 pages, Chris?
36, I believe, is the target.
Okay, but I think 40 is the next target, and then who knows where we're going from there. But when I became president, there was no way that I could be the editor and the managing editor and the editor all at the same time. So I actually met Chris at, I think it was Okie-Tex, right? That you and I had this discussion, like, what are you doing for the next 20 years?
Yeah, that was the AVSO meeting.
AVSO, that's right. What are you doing for the next 20 years? And you said absolutely nothing. I said, good. How would you like to be editor? And you kind of thought about, I don't know, 15, maybe 20 seconds and said, yeah, why not? And those are the words that I use. So I decided, okay, Chris, you got it. You were the only poor fool that was interested. So I said, okay, great. And to be honest with you, you have done one absolutely hell of a job. You've done a better job than I could. And to be honest with you, I never thought I'd ever say that to anybody. But you have done a wonderful job. And it is with a great deal of pride that we present you with the GR Wright Award for your work as editor of the Reflector magazine. Thank you very, very much. Okay. Now, prior to Chris coming on board, let's see, I hired Carla as advertising. I hired Kevin Jones for his editing. He said he could edit just, huh? You gonna cry? Don't cry.
Yeah, I'll go put him
up. Yeah, don't cry, Chris. Kevin, I talked to, I think, a couple of times, and he said he had the ability of editing just by looking at something. He said he could look at a page, pick out the edits, and I said, yeah, sure you can. And he proved that he could. And Kevin, you did one hell of a job. Okay, you and Chris were the associate editors, and you're still doing that. And from what I've seen, you're doing still a bang-up job. So thank you very much. Hold up your award. Hold it up. Come on, don't be bashful.
Yep, thanks very much, Ron.
I actually now know what you look like. I never met you before.
Yeah, this is the first time I'm seeing all these people that I work with. We just
exactly
we deal on email completely.
Exactly. Okay. I see a couple of others, but Carla, when you and I chatted, we were looking for an advertising person. I think John Goss was doing the advertising at that point, and he needed help. And boy, did he need help. And you and I chatted. I met you once somewhere. Where were we? I was in Colorado or where?
We're in Casper.
Casper, that's right, during the eclipse. I'm an old man. You have to forgive my memory. I'm starting to, lose it. Yeah, but I met you, your husband, and where'd you go? And your dog. Still got the dog? Still got the husband? Okay, way to go. And Carla has done an absolutely bang-up job, because if it wasn't for the money that Carla generates in advertising, we couldn't afford to create such an incredible magazine. So thank you, Carla. Pick up your award, show it to the world, and you did great. You're beautiful as always.
Nice to meet all of you that we've only corresponded via email. Lovely to see you.
Exactly.
Nice
Isn't
to meet
that,
everybody.
isn't modern technology wonderful?
Yeah. I see
Now,
you.
who else do we have? Oh, Dan,
Dan.
that's what you look like. Okay, I think I've met you before too. Dan, I was looking for a photo editor. I needed somebody who could take literally at that time, hundreds of photographs we were getting for every issue, sort through them, pick out those that went into the gallery, pick out the best ones, make sure the information on them was correct. And he has done an absolutely incredible job as well. And if I ever get into imaging, I will be picking your brain. There may not be much of the brain left by the time I'm through picking it, but I will be picking it thoroughly. Dan, please put your award up to the camera. Take it off of mute. Take it off of mute. Thank
Sorry,
you.
someone else muted me. Thanks.
Okay.
Welcome.
Thank you.
No, thank you. Thank you. We are missing a couple of people, I believe.
Yes, we are missing
missing,
Michael Patterson and John Wagner.
Yeah, we're missing Mike Patterson, who I will say in absentia. We had a young man who was doing the editing and the publishing part of it for many, many years. It was actually Jackie Beach's brother. And he did a wonderful job, but he was getting, as he said, he was getting too old to continue. And I really felt bad when he retired. And we needed another person. And Mike Patterson, who had been doing this kind of work for years, for many years, stepped up to the plate and said, yeah, I'll do it for a year. And here we are almost 3 years later, and he is still doing it. So Mike, wherever you are, you better be holding up your plaque to a camera, all right? Otherwise, I'm going to come there and take you down. But thank you, Mike. And then John Wagner, we have another award, a special award, since he already received the G.R. Wright Award. And John Wagner received the same special award that I did for all of the years. And here's the only one I have not hired. I've hired everybody else, but here's the only one I did not hire. And again, another one who has done a great job. So to all of you, to each and every one of you, thank you from the bottom of my heart. I really appreciate what you do. The League really appreciates what you do. And I don't think we could have created a publication like we do without your help. John Goss, that includes you, because we had some big shoes to fill when when Carla took over your spot. Chris, you had some small shoes to fill when you took over mine. Kevin, you aren't doing anybody's job, so you're brand new at this. Dan, John Wagner is actually a photo editor for a while, okay? And you took that, okay, because we just needed somebody that was more in tune with the photography that was happening at the time. So, ladies, gentlemen, thank you all. It is greatly appreciated. And I'd like to give you all a hug. So you're going to have to get a virtual hug out of me if you don't mind, okay? Thank you. Thank you very much. Everybody, give them a round of applause. Without them, there is no magazine, okay?
Along with that, at the same time, we were talking about should we honor for keeping our communication flowing through the pandemic. I was talking to our treasurer, Bill Dillon, and he says, our printer has just gone the extra mile throughout all of this. They're always helping us out, extending deadlines. And I thought, well, it's a little unorthodox, but why don't we give them a plaque? And we did. And I got the nicest letter about 3 days ago that says, we are not used to being on the receiving end of accolades. We just do our job. And I thought, wow, I think we made a good decision there.
When I talked to Mike about that, he was very surprised. And when I talked to Randy Cunningham, who's the sales manager for Sundance Printing and Publishing in Arizona, he was floored. He said, yeah, he had never gotten anything like that in his career. So I wish he could have made it. I don't know if even he was sent the link. I thought he was sent the link to this, but maybe not. But I will tell him that we appreciate everything again. So ladies and gents, again, thank you. You've done a bang up job, and let's continue to do it. And next up, we have to take out, we have to get our subscription rate above and beyond what Astronomy Magazine is doing. They're sitting at around 65,000. So, you know, we've got a little ways to go.
Thank you again, the whole staff.
Thank you very much, all of you. Thank
now
you.
Back to Chuck or.
Yes, thank you. In the last roughly 10 months, I think I've given about 44 Zoom programs to clubs around the league. And I can't tell you with what pride I go to these clubs knowing that they get the reflector, because they all comment about it. It's almost a constant how pleased they are with it and how impressed they are with it. So I'm just really thrilled about this award going to the reflector staff. You've all done just an incredible job. It's amazing.
We aim to please.
Thanks, Ron. Next, I'd like to introduce John Goss and Tom Lynch. They will be providing us with a description of our library telescope program and new library telescope award, and also the giveaway of 11 library telescopes. John, I'll let you take over from here.
All righty, thank you, Chuck. Before I begin, I want to reiterate what everyone has just said about the Reflector magazine and what it has become. I think sometimes we lose sight of that the Reflector really is the face of the Astronomical League. It's what people see. Of course, we have our awards and observing stuff, but that Reflector is something people can hold in their hand and prove that the Astronomical League is a viable, important organization. So thank you, Reflector staff. I appreciate it. I'm sure all our members do. I'd like to talk to you about the Library Loaner Telescope program. I'll try not to get too excited about this, because this is, I think, a very, very wonderful program that has been, I think, literally sweeping across the country. I became interested in this in 2011 when I became interested in it. I heard about it at a star party. And I heard about somebody in the New Hampshire Astronomical Society. His name was Mark Stowbridge, who, not by himself, but he certainly was a force to reckon with for this. He came up with this idea of loaning out telescopes. Now, of course, this is not a big idea, a new idea at all. I think most clubs have a number of telescopes in their inventory, which they let members use and maybe interested people of the public. But this program was different in that the local library would be the organization that would handle it all. Essentially, what he was envisioning was that a club would donate a small, easy to use telescope to the local library, and they would put it in circulation and offer it just like they would a book. Members of the public could come in and check it out for, I don't know, X amount of time, a week, 10 days, 2 weeks, whatever the library chooses. So it would reach a lot of people who wouldn't normally have access to a telescope. And the idea is that if people like it, if they like the telescope, then they can go out and buy their own and become interested in astronomy. And if they don't, then they just return it and somebody else will check it out. So this program really just took off. Mark and other members of the New Hampshire Astronomical Society really jumped on this and improved the whole idea behind it. And what they came up with, which is still pretty much in use today, we'll be talking about that right now. They came up with the Orion Starblast Dobsonian tabletop telescope, 4.5-inch diameter. For some of us amateurs, we're thinking, 4.5 inches, big deal. What can you see with that? But through the eyes of a newcomer to the hobby, or the eyes of a 12-year-old, or the eyes of parents trying to get their kids interested in science, this is a really good scope. Yes, but it's lightweight. It's easily portable. It is something that the staff of the library won't object having, because they don't want to have some big thing there. They want something that's easy to use. It has that. Mark and his group came up with a way of refitting the telescope with a zoom eyepiece instead of having a couple of smaller eyepieces or a couple eyepieces which could be lost or dropped, misplaced, whatever. They'd have a zoom eyepiece in there, which would be more or less, sometimes less, permanently placed. So I was just saying, it's very easy to carry. I think it only weighs like 11 to 13 pounds. So just pick it up. It has a nice, easy carrying handle. Check it out from the library, pick it up, put it in your car, strap it in like you would a person, and drive off with the telescope. It's a really great program. I was mentioning about the zoom eyepiece. It's used, some modifications are done, for instance, to put some set screws in so the zoom eyepiece can't be easily taken out. Yes, it can be taken out, but not easily. And it's easy to use. It goes from 24 millimeters down to 8. You see, it says it's 8, which means that this type of telescope, the magnification ranges from 32, I think, or was it 24? 32 power up to 60. Okay, it's not extremely high power, but again, look at it through a kid's eyes. Someone wants to look at the moon, you can see craters on the moon. Somebody wants to look at Jupiter, you can see the Galilean moons. Somebody wants to look at Saturn, which everyone does. There you see the little rings of Saturn. It really works. Just went over that, skip that. It also comes with a finder scope. One moment. There are several ways of doing all these modifications. So there are several ideas of finder scopes that it comes with. There's something called the red dot EZ finder, which is pretty much self-explanatory. It has a red dot in it. You point it at whatever object you want to look at, such as the moon, and it pretty much centers it. There are other ways of doing it, which is something we call a tube finder, which is just essentially a hole that you sight up. Again, finding the moon, it should be centered in the eyepiece or right next to it. Speaking of the eyepiece again, this is only, I think, an f4, maybe it's an f5. So its field of view is really very large. It's like 2.5 degrees, 2.25 degrees, 2.5 degrees. So it's easy to find the moon and put it in the field of view. Then you zoom in, of course, the field of view drops, but the magnification goes up and you can see, for the moon, you can see easily craters on the moon. Always think of it through a kid's eyes or a newcomer's eyes. Another interesting innovation was what we call the moon port. As you can imagine, the full moon is pretty bright, or the big gibbous moon is pretty bright. So other than having the people wear sunglasses when they look at the moon, what we've done is cut a hole in the front end cap, and about a 2-inch hole, and that really cuts down the light of the moon, makes it easily seen and not painfully bright anymore. Okay, there are a couple rules here. One's obvious: you never look at the sun with it. And we have stamps, stickers all over the telescope reminding people never ever look at the sun. And of course, never ever drop it. But if you don't drop it, these things can last quite a while. I think people are extra careful when they're around a telescope like this, because they think it's a quality science instrument, which they're right, but it's not exactly it's not extremely fragile, but you want them to think that, and I think they treat it very well. So what can you see with this telescope? Well, this is a picture that I took. I didn't draw it, of course. Picture that I took. So there's plenty of craters and detail on the moon. So imagine you're a kid and you're looking at this for the first time. You're going to be pretty impressed with this. This telescope generally comes, we have available maps of the moon and star clusters and maps of the sky and such. So people can find interesting things to see and identify, like on the moon, you can identify certain craters such as Aristoteles crater up at the north edge. You get the idea. You can also see crescent of Venus, very easy to see. When it's a small gibbous, it's tough to see, but its crescent phase of Venus is really good. Deep sky stuff, surprisingly, Yeah, this 4.5-inch telescope can reveal quite a bit. I personally drew these two pictures. One was at the lowest power of the Orion Nebula. Okay, we've all seen that 100 times. But again, think of a newcomer, of a kid or a parent looking at this type thing for the very first time. Now you can see quite a bit of detail in it. Zoom in on it, you can split the trapezium for this small telescope. Very portable, easy to use. So the way I look at this type of thing is it's a win-win-win-win, and you can add some other wins on the end there. You know, it's a win for the library patron, the kid. It's a win for the library, because the libraries they like showing that they're being used. They like telling the public that you can come to the library and use many of what they have to offer, such as this telescope. The library offers other things besides besides books. So why couldn't they offer this little telescope? And it's a win for the Astronomy Club, who donates this telescope, who modifies a little bit to make it more rough and ready type, so to speak. And it's a win for amateur astronomy and science in general. Everybody wins on this. We have a lot more information on this. I'm not going to go over this. This whole presentation is divided up into three components. There's what I'm talking about now. In just a moment, I'm going to talk about the library telescope drawing program that we have. And I'm going to turn things over to Tom Lynch, who is an expert at the library telescope award program that the Astronomical League offers. He's going to talk a little bit about that. But these two websites will tell you a lot more about this wonderful program. The club that I belong to, we have 12 or 13 of these telescopes being loaned at all times out there. That's another thing. How popular these are with the public. Generally, the telescope is always loaned out. There's a waiting list. Hopefully, not a very long waiting list, but there's a waiting list. So you have something a lot like this that's into the public's face all the time with astronomy. So it's a big win. So you take it home and you enjoy it. We also have handouts on these websites that I just gave about how to find your way around the night sky, for instance, how to find some of these neat objects, both English and Spanish. We generally have an object of the month or a feature to look at in the month. That telescope would be super to use. So let me exit that. And let me also say, though, that this is a wonderful club activity. Just think about this. You know, you have your club meetings, and so what do? A lot of clubs just they have a feature meeting, a speaker, and they may go out and observe once in a while. A lot of times they don't. Well, this is an actual project that a club can get involved with. Purchase this telescope and do the modifications, which would be listed on those websites I gave. It's not hard to do. Somebody has to do it though, and then donate it to the local library. The total cost of this is somewhere around $325 to $350, depending on what type of deal that you can get. Right now, of course, you know there's a big telescope shortage, so there's a waiting list before you actually get it in. But it's still a great deal to do. So with the league's been interested in doing this for quite a while. So I think starting in 2015. The Jack Horkheimer Charitable Fund gave a donation to the league to promote this program. Essentially, that's what we've done. And we decided to give away telescopes, one to each region of the Astronomical League. So that's 10 telescopes a year, plus we're going to give away one to the members at large. The only deal is that you have to apply for this. So this year, we held a drawing, and I'm going to announce the winners of the Library Telescope program now. Before I do, I'm going to scold everybody because we missed opportunity. I don't want to go into all the details, but we had $1,750 worth of telescopes go unclaimed. And that's because we didn't get enough applications for this. So next year in the 2021-2022 cycle, please put your application in and you'll be eligible for the drawing. Before I read the names off, I also want to emphasize that if your club did put in an application and they are not selected, it does not mean that your club is not worthy. It simply means that they were unlucky in this drawing. So don't give up and don't take this as a slight at all. But these are the winners for the Southeast region of the Astronomical League. The lucky winner was the Caddo Magnet Astronomy Club, which is headed by Ashini Modi. For the Western region of the Astronomical League, we have a repeat winner because I do recognize that this name, the Tucson Amateur Astronomy Association. Mid-States region of the league, I think this is a repeat winner too, the Kansas Astronomical Observers. The Northeast region, I think this is a new winner, Skyscrapers from Rhode Island. Northwest region, a repeat winner, Island County Astronomical Society, and I saw Bob Scott, their member, on the list right there in front of us, so he's there. MAL, David Knighton won it for that. So these 6 winners, I will be notifying them tomorrow, sending an email out to them. And over the next few weeks, probably over the next couple months, they will receive the telescope plus a Zoom eyepiece to install with it. And I think this is a great program. I'm really happy that they applied to do all this. This is an excellent opportunity for them. As I was saying, it's a win-win-win-win, and you might be able to think of some more wins that you can add on to that. So with that, I think I'll turn things over to Tom Lynch, who will talk about a slight variation on this, the Library Telescope Award Program. So Tom, are you there right now?
Yes, I am. I'm about to share my screen.
By the way, Tom Lynch is with the Amateur Observer Society of New York, so he's coming to us from Long Island right now. And he himself has had a lot of experience at placing a number of telescopes and battle-tested experience. So I'm glad he's with us helping this out.
Okay, can you guys see the screen? The Library Telescope Award?
I can see you.
Okay, my screen didn't share then. Hold on a sec. How about now?
Yes.
Okay, great. All right, so I'm going to talk about the Library Telescope Award. The Astronomical League recognizes that there is effort put into this program, and it's a worthwhile program. So they came up with this award, and you do library telescope activities to win certificates and eventually a pin. There's a picture of the pin right there. And I know we all like our pins from the Observing Awards. So this is just a little bit more encouragement. So to get the Silver Award, you need 20 hours of library telescope activities. And I'll explain that in a minute. And to win the Gold Award, you need an additional 80 hours for a total of 100 hours to get the certificate. And then you also get the pin at that point. So what are library telescope activities? Well, oops, there we go. Okay, so promoting the library telescope program to libraries and the general public. Part of this is really just getting to understand what it is, that it exists. We've been doing that quite a bit. There's a Astronomical League Library Telescope Task Force that meets on a monthly basis through Zoom. And we've got about 40 people involved at this point. So we're doing as much as we can there. But this, obviously, if you're going to do this, you've got to find local libraries to explain to them what the program is, because they may not have ever heard of it before. So explaining it is the second one there. And the third one is modifying the library telescopes. So John explained some of the modifications, and they're really pretty easy. I mean, if you're a handy person, it's no big deal at all. I'm not that handy, but I've been modifying them now for almost 5 years now. I've probably done about almost 15 to 20 telescopes, and it's really not that hard. Instructing the library staff in the care and use of the telescopes, that's a big deal because, first of all, they may not be all that interested, right? I mean, they work at the library, they might be checking it in and out, they might be carrying it. It's important that they understand how to do it. And, you know, they may or may not care about the telescope. So it can be a little difficult here to get those folks to understand it, but it's definitely doable. And then instructing patrons of the library. And this is a lot easier because these people are motivated. They came to a session to learn about the telescope and how to use it. I like to tell people that I can teach a 10-year-old, a motivated 10-year-old, to use the telescope in about 10 minutes. And adults take a lot longer, but you know they tend to be not as motivated and perhaps a little nervous to make a mistake, whereas the kids don't. They learn pretty quick. Doing periodic maintenance on the library telescope. You know, that's an important piece. It has one of those red dot viewfinders, and you know that gets the battery goes dead because people forget to turn it off. It has issues with the alignment because people turn the wrong knobs and put it out of alignment. So that's a big deal, cleaning the lens, etc. And participating in library start parties, which I've done quite a few of these now, where we have people come with their own telescopes perhaps, and then we also have the library telescope there, and we get a chance to teach people how to use it there as well. So those are the activities that you need to come up with. And I think John mentioned this before, that this is a great club project, but it can also be done by one member. We've had several MALs, members at large, that have done it themselves. In order to get the award, you have to be a member of the Astronomical League, either through your club or as a member of at large. And when we put this together, we decided that we would go back to July 1st, 2015. So any time put into the library telescope from July 1st, 2015 through the present can be used to get to your 100 hours. So I thought we'd have a lot of people get this real quick when we started it in 2020. I haven't had as many as I thought we would, but it's continuing to grow. This is a flyer that could be used to send to the library to tell about what the library telescope is like, what it does. This picture up here on the upper right, that's the recommended way to carry it. It's sort of the football hold. You put it into the fold of your arm and you pull it towards your body, and then you have a hand free to open doors and maybe block middle linebackers as they come in to tackle you. But this flyer is kind of cool. It tells you, what to do, what it's like. It's a kind of a good one-pager to send to the library or drop off at your library to maybe then get them to participate. Okay, and here I have a series of links to various information, that flyer being one of them, but also to various websites and things for more information about the library telescope program. Okay, John, you want to come back on, or we're going to pass this on to somebody else?
Well, I don't have much more to say. I do have one question, Tom. Sure. Does this award apply for a club or for a person in the club?
Oh, it's an individual, right? It's a person in the club. So each club, they're much like the observing awards. You put the time in, you fill out the form, you send it in to me. I'm the coordinator of it, and you get your pin. So it is, it could be a club event, a club action, but individuals are the ones who get this award.
Okay, thank you. That's all I have.
Anybody else? Okay, thank you.
Okay, are there any questions for John or Tom from anyone?
I'll follow up on John's question and just say that it's a lot like the Outreach Award. A lot of the outreach programs are done as clubs, but the club doesn't seek the award, the individuals seek the award. So it's, if you think it's unusual that a club would do the library program, but the individuals go for it, it's really patterned after the outreach award. So it's very, very similar to that.
Yeah, exactly. But in fact, I copied most of the information about it that goes into the award from. I started with the outreach award and then just modified that. So yeah, it's very, very similar.
I want to say, Tom, that it's a great new award, and thank you for developing it for us. It's really fantastic.
Well, thank you. There's been a lot of people. I like to always mention Mark Stobridge, who we call the father of the Library Telescope program. He's the one who started it up in New Hampshire. There are probably more library telescopes in New Hampshire than anywhere else. I think Missouri is getting close, but there's a ton of them up there. So they started it and did a great job with it. It's really I agree, really a great program.
And I neglected earlier to properly introduce John. John Goss is a past president of the Astronomical League from 2014 to 2018, and is now the League's media officer. He handles our Facebook page and all of our social media, and he's also producing a great deal of our YouTubes on our observing program. So John, thanks for everything that you do with us.
You're welcome.
One last little bit of business before we go to the final door prizes for tonight. Would like to introduce a young lady who cannot be with us tonight because she's off to college, which I alluded to being a problem for some of our young people. Could we stop sharing the library telescope?
There we go.
Okay, great. Thank you. Let's see here. Okay, oops, hang on just a moment. Okay, I'm going to start over. Okay, I've got the wrong program here. Let me get the other program back up. Here we go. This young lady's name is Karen Lee, and Karen last year in 2020 was a rising senior at Saratoga High School in Saratoga, California. And she's off to college now, but we're awarding her the 2020 National Young Astronomer Award. She won this award and the telescope prize from Explore Scientific as a result of an incredible project she did back in 2020. She got started in astronomy as a high school freshman after looking through her father's telescope, and the next year started an astronomy club at her school and served as president of that group. Her astronomy project was to identify an unknown source of detected 21 centimeter neutral hydrogen emission. Astronomers had not determined the source of this emission, and she built her own radio telescope and began studying this source and wrote a paper on the characteristics of this source. And using the radio telescope determined the right ascension and declination, the brightness temperature, and the velocity relative to the local standard of rest of this source. After calculating that, she went to the database SIMBAD and tried to find out which of 20 objects that met some of these criteria matched the initial criteria of the hydrogen emission line, right ascension and declination. She found 2 objects that met these criteria, and she then compared the brightness temperature to the 2 objects that she found. And she was able to determine from this resource that both of these sources, FVW 173.0 and FVW 173.0 plus 0 and plus 3 qualified as the sources, the combined sources of this 21 centimeter emission. So she actually discovered the source of this previously unknown source of 21 centimeter emission. She's had the privilege of visiting Mount Wilson and using the telescope there, actually. She studied the field of radio astronomy extensively since becoming interested in astronomy. And she is a 3-time American Invitational Mathematics Examination qualifier. And she has received her plaque last year for winning the National Young Astronomer Award, again, in a very rigorous competition against projects that just really gained tremendous praise from our judges, who are all professional astronomers and science fair judges. So congratulations to Karen and good luck in college. And I'm sorry you couldn't join us tonight, but I understand. Okay, with that, Terry, you're muted.
Try that again.
There we go.
Prizes.
We have a few door prizes to give out and to close the evening. I would like to say one thing before we do the door prizes very quickly. Tomorrow's session begins with a business meeting. Now, that may sound maybe a little dry to you, but it won't be. It's going to be a summary of what the league is doing. Not a bunch of detail, but we're going to be talking about future conventions for the next 4 years. We're going to be talking about a major overhaul of our website. We're going to be talking about the new international region that we're developing. We're going to be talking about our trust fund and treasury, also some of the outcomes from our recent virtual council meeting. So I hope you will join us. It will be very informative and not terribly long. So please try to tune in for that. Okay, let's do a drawing first of all for the Hill County astronomers. And I'm going to share screen on that. And let me stop share. I've got to go back to the right screen again. Hang on. Okay. I'm just going to show this logo here to you, as I promised I would. Okay, can you see that?
Yep.
Yes.
Okay, I won't enlarge it. The Hill Country astronomers are in South Central Texas. It's Lyndon Johnson territory. And they have contributed a $200 gift certificate to Scope Stuff. And I've looked at their website and they have a very wide variety of products to sell. And they're supporting this organization, this company, because it's local to them. And I think that's a wonderful thing for them to do. So without further ado, I will stop sharing and we will go. This time I'm going to check it out to make sure I've got the right page up. And we'll do the random number drawing. Okay, you ready?
Yep.
We will go to number 198.
All right. $198 is Todd Morgan.
Okay, Todd, you have $200 worth of Scope Stuff coming to you. Congratulations. And next, we have the Northwest Suburban Astronomers. Is Mike Schiller with us tonight?
I am. Hi, Chuck.
Hi, Mike. I'm sorry it's taken a little longer. We ran just a little bit over. I apologize for that. Welcome. And we're going to draw your prize first, which is as I understand it, a set of 8x42 deluxe overwork binoculars. Is that correct?
Correct.
Fantastic prize. And let's do the drawing first of all. Okay. And the winner will be number 436.
I've got it.
Okay. And while she's looking up that, Mike, why don't you tell us a little about your club, Northwest Suburban Astronomers?
Great. Thanks, Chuck. Hi, everybody. Northwest Suburban Astronomers is a club of about 160 amateur astronomers. We've grown quite a bit over the course of the last year. I think COVID has really seen, at least certainly our club numbers, increase. We are located in the Northwest Suburban area of Chicago, Barrington, Palatine, Harwood, Hoffman Estates area. We are a club that does a tremendous amount of observing together. We've got some really rich relationships with McHenry County and DeKalb County Forest Preserve districts, and we go out quite a bit as a club and observe on the weekends. We also host a number of STEM and public events at our libraries, as well as a thank you to the two Forest Preserve districts that I mentioned. And we also host 2 club star parties up at Wildcat Mountain, and we offer a public up there. So it's a great club. I can tell you I've been in the club 10 years, and what's really interesting is seeing the shift from more strictly observing to more imaging. And I think it's because we're seeing a younger generation come into this hobby who are very tech savvy, very attracted to technology, and you've got this convergence of tech and a lower price point on some of this excellent gear that's coming out to go ahead and begin to capture and image some incredible objects, deep sky objects out there. So it's a great club, and we're really proud to be members of the Astronomical League and to offer up this door prize. These binoculars are fabulous. They're all collimated, and it should bring a lot of viewing pleasure. 2 eyes are better than 1, as they say.
Well, we sure appreciate your contribution of the door prize. I have a pair of Overworks, and they are the best collimated binoculars I've ever used. It's just incredible. No double vision at all. And I understand you have a young person in your midst named Tyler Westering.
Yes. Yeah, we're very, very proud of Tyler. And you guys honored him a little bit earlier this evening. So
Yes.
fabulous. I mean, he's indicative of what I was mentioning, right? This move to, at least in our club, we're seeing younger astronomers or younger hobbyists come into the club, and they're all coming in, and they're all attracted to the imaging side as opposed to the observing side. I think it's the Hubble generation, right?
Yeah.
The Andromeda, they see these other deep sky objects, and just looking at an eyepiece, it doesn't bring the same pleasure as you get when you're actually imaging it.
Well, you're doing a great job, and thank you very much again. And Terry, who is the winner of the binoculars?
Looks like Andrew Buchan will be enjoying those 8x12 deluxe overwork binoculars, value about $172.
Fantastic. Thanks again, Mike.
Thank you, Chuck. Thanks, everybody. Thanks for all the great work you're doing, too.
Thank you. Okay, is Dodie Reagan with us?
Yes, I'm here, Chuck.
Hi, Dodie. How are you doing?
Yeah,
Dodie's with the Texas Astronomical Society of Dallas, and they have contributed a pair of Nikon Action EX 10x50 CG binoculars, valued at over $210, I believe. Is that correct?
That is correct.
Okay, we're going to draw the number, and then I'll have you talk about your club. Sorry to interrupt you for just 1 second. Give me 1 moment to do that. Gives Terry an opportunity to look up the winner, and here we go. The number is 801.
Thank you.
Okay, and I'll stop sharing. And Dodie, tell us a little about your club.
Okay, I'll share my screen here.
Sure.
Can you see that?
Yes, we can. Yes.
Okay. Yes, Texas Astronomical Society is one of the larger clubs in the country, a little over 500 members, and we've been around since 1956. We have a nice Bortle 3 dark site about an hour north of us up in southeastern Oklahoma. That's one of the important parts of our club. We have a new bunkhouse there and getting ready to put some new bunks in it. We have concrete pads with power and a nice observatory there with a Meade 16-inch in it. We do weekly public star parties throughout the Dallas area, of course, when we're not in COVID. Really, outreach is one of the, I'd say it's really the heart of our club. We do a lot of things with a lot of local groups. I'm very fortunate to have events like the Moon Day in Dallas that we've participated in for the last 10 years. We do Astronomy Day at one of the local colleges. Our meetings, monthly meetings, by the way, are sponsored by the University of Texas at Dallas. They're very generous. We appreciate that. We're very involved with the Girl Scouts. We have volunteers who participate in a volunteer fashion at Texas Star Party also. We do some things with the Texas Parks Department at a couple of the local state parks. Outreach is just an important part of our club culture. We have also a few special interest groups, like the other gentleman was saying, astrophotography is huge in our club as well. So we have a special interest group for that that's been around several years. Plus we have a group for beginner astrophotographers. And we have a special interest group just for newcomers. It kind of focuses on the observing side of things. Also have a special interest group for the ham radio operators. It's been around for a while. And we tried really hard during the pandemic to keep up the quality of our speakers. And I've listed some here that we've had over the last year. We've been very fortunate to have some excellent speakers. Try to keep up with that. And the next slide shows the door prize. That's the binoculars right there.
Excellent. Dodie, we really appreciate the contribution, and I've had the privilege of speaking at your club before, and it's a fabulous organization, and we really appreciate you being here tonight. Thank you.
Thank you all for everything you do.
Thank you very much. And that's all I have, Terry.
Okay, Chad Stovall is the winner of those binoculars.
Congratulations, Chad. And that should do it for me for tonight. Terry, any final words?
That should wrap us up. Everybody join us please tomorrow, 3 p.m. Eastern Daylight Time tomorrow. As Chuck said, there'll be a business meeting. We've got David Levy giving a talk about Carolyn Shoemaker. We have a SLU presentation, and Kareem Jaffer will also be speaking tomorrow. So please join us tomorrow, 3 p.m. Eastern Daylight Time, right here.
Okay.
Good night, everybody.
Hey, before we go here, there was a last question about the library telescope link. And I just wanted to know, I just wanted to give that to them. Is it librarytelescope.org?
Is Tom Lynch still here? He can probably answer.
Tom, are you there?
Yes, that's right. Librarytelescope.org. And there's also a Facebook page, Library Telescope.
Okay.
Page.
I'll give them that in chat before we officially sign out. And we had a great audience today, so it was tremendous. And, you know, really someone watching the presentations, it was top notch. It was great. So.
Thank you to all of our speakers.
Hats
and
off.
all of the clubs.
Yeah. Okay. All right. So we want to thank you for watching. We will be back at 3 p.m. Eastern Daylight Time tomorrow and the next day as well. So until that time, you guys keep looking up, and we will see you later.
Good night.
Good night, everyone.
Night.
Go back.